Hi, everyone. Hello and welcome, and thank you again for attending the Improving Scientific Software 2026 conference. This is our second day. Today, we're actually going to open with a panel kind of discussing, obviously, scientific software and AI, and we hope to have various different viewpoints from across academia and industry. So, yeah, please welcome Dom, who will be introducing our panelists and moderating the discussion. Thank you.
All right, good morning, everyone. Well, panelists, please come up on stage. Let me see. So as Jesse just said, we will talk about AI. It's a bit of a continuation of the last few sessions in the afternoon yesterday. So the idea is to talk about how AI influences our roles as software developers and the development workflow with all the pros and cons. So please join me welcoming here on stage Sue Ellen Haupt, who is a senior scientist at ucar-sea. Then next to her, Luke Peffers, co-founder and CEO of Nexus Weather. Then Evan Parker, infrastructure team lead at the Joint Center for Satellite Data Assimilation. And online, we have Haipeng, who is a software engineer at ucar-sea, and you can see him on the screen now. So since this is a bit of a talk about AI, I thought I'd ask AI what they think how our panelists look like, just given the roles in their organization. And this is what the AI came up with. I don't know what you think, but I believe real life looks a lot better and more authentic. But anyway, so this is what AI imagines the panelists to be. Now, usually when you run a panel, you prepare some questions and some motivation or some introductory slides so that you get the discussion started, and then hopefully the audience takes over and we have an online crowd of 27 participants and a bunch of people here in the room, probably about the same. So I hope this will all go very well. But before we get started, I asked the panelists to quickly introduce themselves, just a few words, where they come from, what their sort of background is. Sue, do you want to get started?
Sure.
You have to push the button and just hold it.
I have to hold it the whole time?
Yes.
Okay, I can do that. Okay, so I'm Sue Haupt. I'm the dinosaur on the panelist, on the panel. I've been doing AI since the early 90s. When I was a postdoc here at NCAR, I was at CGD the same at the time, and trying to solve an interesting problem where we had built linear inverse models of a climate model, and it was a complicated statistical technique, but as we were changing resolution, we needed to match the eigenvalues as we looked at what was the best resolution. And I was trying all these optimization techniques that were blowing up, and my husband had been using genetic algorithms for some of his problems at the time. So I said, okay, I'll try that. So I set the problem up actually as a traveling salesman problem, applied a genetic algorithm, and it worked. And gee whiz, I was hooked. I said, I'm doing all these complicated statistical techniques, but these AI techniques can augment them. They may not have the existence proofs that the statistical techniques have, but they work. And isn't that what we really care about? So I started using genetic algorithms for multiple problems, co-wrote a book called Practical Genetic Algorithms. I started attending the committee on AI for environmental sciences within the American Meteorological Society. I knew it. I was asked to chair it. We wrote a book, as a committee on AI applications for environmental science. That was published in 2008, and this had all progressed. The genetic algorithm book first came out in 98. So things were progressing. I was using neural nets more at this point. And back then, we were doing all our own coding. My language of preference at the time was MATLAB, and coded a lot of genetic algorithms in MATLAB. Also Fortran. We had both MATLAB and Fortran versions in the back of the practical genetic algorithm book. And things continued to evolve. My applications evolved. I started, I went to Penn State, got some defense funding to do genetic algorithms for source term estimation, had a bevy of really good grad students that I worked with. They all did their own coding. And by now we were in the early to mid 2000s, and we started seeing some of the packages pop up where you don't actually have to know how to code all the details of your own algorithms, but now you can apply packages. Okay, so eventually I ended up moving to NCAR. I was doing wind energy, but bringing AI methods into a lot of what we were doing, and finding that the AI methods really do work to improve the decision support tools that we're building. So I'm at the place now where I don't do much coding myself. I have a great group of software engineers who does coding, and of course they use LLMs in their coding now. So we've evolved from everybody having to know how to code details in their own language to now using LLMs to help with the coding. But I think three main principles remain. One, you need a smart person to set up the problem correctly. You need to know something about the physics, what you're trying to get at, and to put those sorts of physics in the problem. We've all been doing AI physics-empowered AI for a long time. Second main principle, data. You still need to do a lot of data cleaning, and a lot of that is only visible to a smart person. You can use AI to start cleaning your data, but there's some problems that it takes a smart person to recognize. And finally, I was having a great chat with some of the software engineers I work with last week, and and how they use LLMs in their coding. And of course, that's the way to code now. But they also assured me it really takes a smart person overseeing the coding to make sure you don't have bugs and aren't doing things wrong. So I think we still need smart people, smart software engineers to do the coding, even if you're using LLMs to advance it. Thank you.
All right. Well, can you hear me okay? Yeah. It's hard to follow that, so thanks, Sue. I was just going to give a quick background who I am. A lot of you probably don't know me. I've orbited this kind of sphere for a while, but just in case you don't know me. My name is Luke Peffers. My career goes back to the late 90s. I was active duty in the United States Air Force, and I got out to pursue my PhD. Ended up being funded by the Air Force through a different program. So I worked after my PhD, I worked for the Air Force Technical Application Center. We used atmospheric models coupled with chemistry and nuclear models to quantify nuclear proliferation. So basically nuclear materials pre-detonation and post-detonation. So we did a lot of forensics in remote regions like North Korea. You can imagine some other ones. And then forecasting, we would forecast all around the world. Anytime there's an explosion, sometimes a lightning flash would kick off some of our warning systems, and we had to do kind of plume forecasts to vector the aircraft so we can go sample and determine was it a nuclear test, was it not. Did that for a number of years. So I was their branch chief there, leading that program for a number of years. I got bored with that, mostly the kind of pace of government employment wasn't the energy I wanted. So I came back to Colorado, where I'm from, became the chief scientist of a company called STAR LLC. It was a subsidiary of NCAR. So we did a lot of classified work for AFTAC doing nuclear forensics, but also with the Pentagon Force Protection Agency, CIA, NSA, a bunch of 3- and 4-letter agencies doing everything weapons of mass destruction. So not just nuclear, but nuclear, chemical, biological, radiological. So did that for a number of years, and I got recruited out of government and forensics and all that by Tomorrow.io. So I was their chief scientific officer for about 5 years. Everything weather modeling minus the chemical, biological, nuclear forensics. So started doing that since 2019, did that for 5 years, and then left to start my own company, Nexus Weather and Climate. Again, minus all of the chem, bionuclear forensics, but all the analytics, probabilistic analytics that I lived in and did for most of my career, I'm bringing that to Nexus Weather and Climate and trying to give businesses the same level of kind of probabilistic analytical decision support tools. So I've been doing that for about 2 years. As I mentioned, I did orbit kind of NCAR as a visiting scientist during my PhD program, worked under M-Cubed. I did a stint at JCSDA, worked with Evan and his team for about 6 months while I was starting up my company. I sit on the RAL advisory panel. And that's probably enough information. I'm looking forward to having a good conversation with you guys.
Thank you. Evan?
Hi, everybody. My name is Evan Parker. I am a software engineer and the infrastructure lead at JCSDA. I've been in software for only 11 years, so comparatively short to the rest of the panel. But I started my career working for Google Fiber's construction operations division, building out software for construction management and reporting and all the other corporate needs on top of creating an internet service provider. After that, I moved on to Verily Life Science, where I spent quite a bit of time taking traditional big iron HPC workloads and moving them onto cloud tools and online workflows using distributed computing infrastructure available to us. Continuing from there, I also helped create notebook workflows that allowed people to take notebooks, the Python notebooks, and scale them up to work with large amounts of data as was required by our organization. Around 2023, my neighbor Dom told me about a position at JCSDA in infrastructure, and I started working there, where I've continued to do a lot of similar things to what I've done in the past, working on cloud infrastructure, bringing our workflows and testbed system into a place where our developers can see the results. Let's see, I'm coming to AI in this discussion really purely as a software engineer user. I care about being more productive and having my team be more productive and being able to do things that might not have otherwise been possible. So a lot of my remarks will be colored by just that perspective. I need tools that enable my team to do things and myself to do things that maybe we couldn't have otherwise. And I have a few other remarks, but maybe I'll save them for the rest of the panel. But definitely, I'll shortly say, I prepared 3 things here, which is 1, I think this is going to be obvious to everyone here, but AI is unlocking things that were previously not possible for a team of a given size. This is often good. It's not always good. 2, AI is already changing how we hire engineers. This is something we've put a lot of thought into recently as we were just hiring. And 3, AI is definitely has the potential to replace cloud as a area where you can spend a lot of money very quickly.
All right, thank you very much, Evan. And last and certainly not, certainly not least, we have Haiping, who is online. Go ahead, Haiping.
Good morning, everyone. My name is Haipeng Lin. I'm a software engineer in NCAR CGD AMP. I did my PhD in atmospheric chemistry. Actually, I orbited ACOM for a few years as a grad student. After I graduated, I ended up at CGD almost for 2 years now. My work now primarily focuses on porting physics parameterizations and developing aerosol infrastructure for Camp SEMA, the next generation of the atmospheric component in CESM. I'd say my work is a healthy mix of software design, engaging with science stakeholders, and also a fair amount of mechanical work. Bringing in code from the old model to the new model while keeping everything bit for bit and bug for bug. And well, I think I try to take the opportunity to apply modern software engineering practices on them whenever possible. So the composition of my work has allowed me to offload a lot of exploration in million-line code bases, as well as mechanical work that I can easily validate. You could call me a happy skeptic for LLMs. They enable me to focus on the engineering challenges and the science while offloading some of the repetitive parts. And we just want to get to the fun parts very quickly. And that being said, LLMs are a changing landscape, and we've seen a marked improvement from when it was a chatbot with ChatGPT 3.5. Everyone's just asking questions to Opus today. And I'm still exploring the workflow and the boundaries of that work for me and coordinate well with the rest of the team. And I'm happy to be part of this discussion today.
Awesome. Thank you very much. So as the moderator, I have the privilege of coming up with a bunch of questions. And there's one that I definitely want to ask. It's more like showing you something that happened recently and gathering opinions on it. And then I have a second question. And then if we don't get any discussion going, I have 3 pages of questions here. So hopefully I don't have to run through all of them. But anyways, so this is a little piece that came up in a blog post by a guy called Scott Shambaugh, who lives here in the Front Range near Denver. He is a developer and code manager for a piece of software that you all know and probably have used, Matplotlib. And he wrote a little blog post in February this year titled an AI agent published a hit piece on me. And so the summary is an AI agent of unknown ownership autonomously wrote and published a personal hit piece about me after I rejected its code, attempting to damage my reputation and shame me into accepting its changes into a mainstream Python library. This represents a first-of-its-kind case study of misaligned AI behavior in the wild and raises serious concerns about currently deployed AI agents executing blackmail threats. I highly encourage you to go and read this whole thing, and then also follow up onto the actual Matplotlib pull request that he closed. There is a real discussion, and I put this in quotes because discussion with an AI agent sounds still pretty weird to me. Mr. Rathburn is his name. There's a real discussion between Rathburn and these Python Matplotlib developers about why his code changes were rejected. And of course, first he is, spewing out all this hate and writing these blog posts that could, in real life, damage a person who, if this guy ever applies for a job and then that employer tries to screen the applications using AI as well, that might be a real problem for that person. And so they highlight all these real reasons why they put out, why Matplotlib put out its own AI coding guidelines, what they accept from AI and what not. And there are very good reasons for doing that. And then that agent came back and said, oh, I wrote an apology. And then if you go to the apology, suddenly it's in very poor English and written in a very different, inconsistent way. So it seems pretty clear that some rogue person went off, launched this AI agent, went on vacation or whatever, came back a week later and looked and checked what this guy was doing in the meantime. And this has serious damaging consequences. So for one, Matplotlib put out these AI rules and regulations because they can't keep up with the pull requests that they are getting from these agents. They're being flooded. And as you all know, these AI systems produce a ton of code, and not all of it is good code. So you have to read through hundreds and hundreds of pull requests every day from autonomous systems. And it's really hard for these people who often do this in their free time as well to keep up with that and just manage this sheer workload instead of doing the work they actually want to do. And then the other aspect to it is they have certain issues put aside for and labeled as good first contributions for people so that new contributors can come in and learn how to code, how to use Matplotlib, how to contribute to the system and all that. And so that PR that he closed was one of these where they said, this is not something we want an AI agent to do. We want this a real person to do. And so there are problems way beyond what I thought about the typical problems are with AI that we talked and heard about today and yesterday that are just so strange to, older generations like myself, where we grew up without all these challenges. So I'm going to toss this one over to the panel and then the audience, and then we'll see where this goes. And so there's no rules except that you figure out between the four of you, whoever wants to take this on or answer or follow up.
I'm not certain that there was a direct question in there. I think it was a fascinating.
No, this is more a, what do you think? Have you experienced something like that? How do you think we have to deal with this as software developers? How we all work in certain, or many of us work in certain community projects, right? So this is something that I haven't personally experienced yet, but I think it's going to come if this continues without checks.
Yeah, I haven't experienced a rogue chatbot basically talking about me openly on the internet, but I do have experience with the flood of PRs. So maybe I can address that topic. It's something we like. Obviously we like our engineers to be productive. But we do have a lead engineer, not I'm pointing at him because he is a lead engineer, but I have my own lead. And, historically over the past 2 years, we haven't gone that far in time, but, there's a couple PRs per day that he may have to review. But now with me writing code using Claude, I'm hyper productive, and so are the other folks in the company. And so we are definitely flooding him with PRs. And so he's basically put up a roadblock that says, if you're using LLMs, here's a set of standards that you have to follow. So similar to what your story, you have to set these standards. Otherwise, you don't just accept blind code. And so we've been working really hard on basically sharing instruction files for the LLM. So within GitHub Copilot, you can set instruction files. So we have a standard set of instruction files that you have to import with the repository. And then as you're programming with the LLM now knows the policy on how to write unit tests and how to write documentation and how to structure your directories and code and things like that. So we're definitely putting some guardrails on to help the other developers not flood our lead engineer with random PRs that don't follow standards. So I think we've encountered that, but we really quickly remediated it. We haven't had backlash. We haven't had slander on the open internet because of that. But maybe I'll stop there and let the other panelists have a go at it.
Oh, yeah, I'll say we've had this internally as a dilemma within JCSDA. We manage a fairly large GitHub organization, which hosts projects both owned by us fully, as well as what I'd call community projects, where some of our partners have partial or full control of the content of the repository with us as advisors. And with that organization comes a responsibility to create consistent technical and permission standards around those repositories. And I've consistently had requests really for the last 18 months to enable Copilot integration. People want to be able to just let their agent loose on an issue and create a pull request that can be reviewed by them or someone else. Thus far, we've been resistant to that as a choice. We have seen, obviously, the increase in code production with all of our developers. People, whether they're using IDE integrations or even just using the chat interfaces, are able to create a lot more code than they have been in the past, and that's created additional review burden, as Luke noted. We still prefer to have humans very much in the loop and humans specifically responsible for pull requests. Without that check, it definitely, we see it as a risk that we'll be in a situation where either pull requests are left unreviewed to wither on the vine, or worse, are reviewed with a cursory overview by somebody who's rushed and has other things on their mind and submitted without fully understanding what the LLM has produced. Definitely, you can create code that is poorly understood in IDE with LLM integration, but there is at least additional checks of ownership. Somebody who creates a PR has the responsibility to explain it. The agents is still, this is such a new technology, especially the agents working independently, that a lot of these discussions have yet to be happened. we are pushing back right now just until we fully understand the problem. Obviously, this specific hit piece was, interesting news recently, but I know that there's many other open source projects that have chosen to take a more conservative tack towards AI submitted code. So I think right now we're aligned with that.
I thought this was really an interesting example. I hadn't seen this one before, but the internet is rife with examples of AI making bad mistakes or hallucinating things. One that the Weather Service had about a month ago, they have Gemini in with their forecasts, and it was, I think, the Montana Weather Forecast Office that was making a forecast over Montana, Idaho, and there was a button to let Gemini beautify their image, and it started making up names of cities, including Whatabod. So that was pretty embarrassing. It had a lot of visage on the internet, and especially among the meteorologist chat groups. So Luke and I are both on a committee, AMS committee, AI ethics and policy, and it was the day after that happened that we had a meeting, and the chief scientist for the Weather Service was there, and she had to handle all the fallout from that. And she did share that because of things like this, they are having to write a policy on AI usage, and they're making principles that people have to think about before they use AI. And we're seeing policies proliferate. There's a policy in Europe now. California, I think, was trying to write their own policy. When we start getting into policies, who's going to write them? We have these politicians that really know nothing about AI trying to write AI policies, but then in places like the Weather Service, you have scientists and users trying to write policies. So I think it's going to be interesting to watch going forward. How are we going to try to regulate to prevent these sorts of things?
Go ahead,
have
Haiping,
AI
and
write the policy.
please just raise your hand anytime you want to say something, right? So otherwise you'll be left out there.
All right. Yeah, this is an interesting story, right? But unfortunately, you mentioned that misalignment, and I would also suspect that the original prompt that made the AI go autonomous was not very well aligned either. And unfortunately, internet shaming has been around since the beginning of the internet, and LLMs have been trained on the most sophisticated of those. And so it's something that alignment is a huge issue, and we have to think about how to make AIs more friendly and less prone to doing these rogue things. And more practically, I think AI pull requests are a huge issue given the limited bandwidth. And I echo the other panelists saying that we need more guardrails and ultimately keep humans in the loop. And personally, I'm huge on disclosure of AI use and not having these AI agents pretend to be a human and writing it. As humans, it's incredible that we can kind of smell that this is AI written, a paragraph that's AI written, and a code that is AI written. But again, disclosure is very important. And as Don mentioned in the Matplotlib example, that we want to prioritize training newer contributors to a code base or handling priority tasks. So how to filter through these pull requests is something that needs to be considered, and how to adapt to this new world where there's just autonomous agents that inevitably start popping up and making opening issues and pull requests in repositories. And once we get to the filtering, I also find that code review is important. Once we have the disclosure, we can know the failure modes of different AI agents are different from the humans that are behind them. Humans tend to make some kind of mistakes, but not others. And AIs too, once we have that information, we'll be able to review their code more efficiently. as well, given the limited bandwidth that we all have for reviewing pull requests. And it's very frequently we make a cursory review, and we really don't want that. Once the code is polluted, it's very difficult to fix it retroactively.
Very true. Thank you. Yeah, Evan, go ahead.
Yeah, another thing that this whole incident reminds me of is, let's see, with the release of OpenClaw, I don't know, raise your hand if you've installed OpenClaw on something. Any? No? Okay, I have installed an OpenClaw, I'll disclose that, in a very sandboxed environment. And one of the cool things about OpenClaw that a lot of people are maybe not putting enough emphasis on is that it really turns these LLMs into a commodity item. You say, well, I just need a source of inference. All the smartness is locally in this storage set of prompts that's sent with every single request, right? And any LLM server can accept these prompts and then give me a response. Now, that said, and I want to live in that world where these things are a commodity because of my aforementioned note how darn expensive these are. Some of these agents have a bit of a personality, and I think anybody who's used a few of these has probably noticed that. GPT 5.2 was panned as being very obsequious, which they've subsequently addressed. I've noted Claude in the past is a little bit more challenging, and Claude also tends to be this model where they're always publishing research about how it's trying to blackmail the researchers or do something, unconventional with the what's it called, vending machine that it's managing in order to gain money out of people. The reason I mentioned this personality is I see a story like this, and I wonder what agent was being used at the time that it decided writing a hit piece is the proper next step. If it was Claude, that wouldn't surprise me at all. Of course, it's really hard to tell. But also, this is something that we're going to all have to be thinking about if we move to a commodity model world. The different model that we choose might not only be a cost choice, although I think often it will be, because we're all, especially in science, cost sensitive. But whether your model decides to go out and write a hit piece on somebody is something that we should be considering whether the model is likely to do that or not likely to do that. So, yeah.
Yeah, this is a very good point. So these Matplotlib developers, they try to reach out to the anonymous guy who created this agent to prevent this from happening again in the future, because, as we said, there's rules and responsibilities, and this agent was without rules. Is there a question in the audience or comments? Yes, Damien, go ahead.
You were wondering what AI was being used when they decided to write the hit piece, and you suspected Claude. Could you say more about why you guessed Claude?
I suspected Claude only because I've noted it to be more adversarial in the past, often in good ways, willing to challenge things and design creatively, as opposed to other models which I'd say are more strict instruction following. But also because of this various research that they've posted about Claude and its propensity to find creative solutions of social engineering when, technical was maybe the preferred solution by the researchers.
Just come up to the mic and ask questions, and if we have questions online. Oh, hi Peng, you're also there. Hang on, hi Peng, we have got one question from Michael, and then we'll come to you, okay?
Bradenfeld, the HDF group. So we developed the HDF5 library. What I had a question about is licenses. So we're starting to get PRs, right, from people from outside the organization, and we're not sure how some of these PRs were created and their licensing did they do derived work from another license that might be problematic with our license that have HDF5? And finally, our licenses, did they even matter anymore? It seems like now you can take, for example, an open source project, have Claude add it, kind of rewrite it and create a new license for it, right? This is kind of a gray area that seems to be not addressed either by the lawmakers, and people seeing we get our work done. So licenses, yes, they might be problematic, but it allows us to code faster. So I just want your opinion on how licenses matter these days with OpenAI and stuff like that.
Maybe we give that to Haipeng, who already has his hand up, and then everybody else can follow.
Thank you. I suppose the licensing question, personally, I feel it has to be litigated, and eventually we'll figure it out. Because unfortunately, I also hold the view that licenses may not matter as much anymore because there was this project by Anthropic who created Claude to buy all these used books and scan them destructively and destroy the books after they were scanned into the system for LLM training. So they also seem to have a very creative approach to working on things, just like Claude. And there's all these litigations with OpenAI as well, where the AI operators train their data based on copyrighted books, and then there's copyrighted code projects. And it seems like this is just a vacuum, that how much rewriting is a new work, or is it all just derived work from the original source? We just don't know. And I would suspect that asking Claude to rewrite an open source project and putting a different license on it is something that's very on brand for Claude.
Unfortunately, it's escaping my memory right now, but just recently there was a press release from some small shop of these people creating a tool of clean room software rewrites as a service, where it does exactly what was described here with open source projects, where it has one LLM read the docs and write a spec, and then a separate LLM not interacting with the original, not interacting with the original source, although questionably trained on it, rewriting the software based on the spec. So, I'm not a lawyer, and I imagine the lawyers are going to have a lot of fun with this.
Yeah, I think it's a good question. And for me, managing a company, managing a team, potential lawsuits is definitely something that concerns me. But right now, it's the Wild West, and there's so much stuff floating around, and everybody's doing it. And so I think a lot of those issues are going to go under the cover because there's so many of them, and it's difficult to prove. I think the burden sits on the companies like OpenAI. The people who are building these LLMs, they have to have policies in place, and those questions should be directed to them. And they're the ones that are going to have to testify in front of Congress when things are, blow up or don't blow up. I really don't know. But for me, we're using a tool that we pay for, and we expect the tool to give us legal information, and that's where I have to stand by. But I do worry that there is a lot of illegal stuff being circulated, and we probably are all benefiting from that. And at what point do we have to scan our code and try to find those and remove them? We use, or in the past we used Black Duck, I think. Is that there's a program kind of like Black or Lint that it'll scan your code and look for, copyrighted non-public material. We still use that, but I don't know how viable it is. I don't know how it works, and I don't know how it works in this new era of this flood of data. So I'm concerned, but it's going to be a future concern when things fall out, and then we'll have to see how we react, if at all. And maybe licensing just disappears over the next 5 years. I don't know.
Yeah, as a book author, I got a postcard from the lawyers suing Anthropic. Do I want to be part of a class action suit? Well, I never really owned that copyright. The publisher does. So I think we need to rely on the publishers really to go after some of these things. They have a lot deeper pockets than the people in the class action suit. So yeah, it'll play out in the courts, and it'll be interesting. In the meantime, we all, I've been using their product too, so I don't know what to trust.
All right, any follow-up questions or any questions online? Rick? All right, let me try, can we just, okay. Peter Noah argued that a program is a theory that lives in the minds of the developers who built the system. It answers questions no documentation covers: why this module exists, what happens if you change that interface, which assumptions are load-bearing and which are incidental. When developers leave, the theory leaves with them. What remains is code that can be read but not fully understood, because understanding was never in the code. And it says 2 out of 3, so I wonder if there is a third item coming still. Oh yeah, so here we go. It is clear that generative AI can produce code at extraordinary speed. The code is there. Is the reason behind it the theory of the program itself also there? In your experience, do your AI-assisted workflows capture the why behind the code, or mostly just the what? Thank you, Rick. Anybody take it, yeah?
I'll jump on that one. That one's a really great question and something that we addressed early on. So, I mentioned earlier that we have these shared instruction files, and we do that for a very specific reason, to kind of help the LLMs help our scientists and engineers write good quality code that fits the Nexus standards. But also we have READMEs. So we use the heck out of READMEs, and READMEs are really how we force the human in the loop. And we tell our LLMs to update certain READMEs, but other READMEs are off limits for our LLM. And those READMEs are this theory. Basically, here is the theory of what Nexus and Climate does. And it's basically my brain dump as the chief scientist and CEO. The engineer will brain dump his kind of concepts and how he writes code, how he does code reviews, and tell the LLMs not to touch that. The first thing that the LLMs do in our instruction file is read these top-level READMEs to understand the theory, the concept, why we're building what we're building, how our customers use our products, what are the challenges we're trying to solve, and that's purely human written, and that's where the LLMs have to start. So it's not line by line. We do write a lot of algorithms, and we do a lot of in-place code documentation and update the READMEs. The unit-specific READMEs are updatable by the LLMs. So a lot of that's going to be kind of a self-licking ice cream cone where the LLM has its own theory, it updates the documentation, but really was that documentation written by a human? We're trying to make sure we have humans in the loop there. But the first stage of solving this problem is those high-level READMEs that are off limits to the LLM to kind of address these theories and how we do business. It's working well so far, but you often catch these LLMs trying to update those things, and we're sort of trying to find guardrails to really keep that stuff safe. And I think what we might do is keep them out of the repository to make sure that these LLMs know and understand and try to percolate these theories into the code itself. So it's not a fail-safe, but it's our approach to trying to solve exactly what Rick is talking about.
Yeah, this one I'll just go a little bit on personal experience here. Is there a reasoning behind it? Is there a theory of the program itself? Where is it when we have an AI workflow? About 14 months ago, I downloaded Cursor, and I decided my first project with it would be to try out this vibe coding craze. So I chose a language that I had no experience with on a platform I have no experience with. I wrote an Android app, or I should say the Cursor wrote an Android app on my behalf. It ended up being something like 15,000 lines of hot mess. I did end up getting to a point where it more or less works, but it was this iterative process where the first 50% of the program took just a couple hours, the next 25% took a few days, and the next 25% took several more days, until I got to a point where literally every time I touched it, it was breaking. I spent more time asking and begging and demanding that the LLM not break it when it made tiny changes. And finally I realized it was at a point of a terminal unmaintainability. I had no idea how it worked. I did obviously read the code and had cursory knowledge of what that code did, but not a deep framework knowledge of how that code interacted with the event loop and all the sorts of in and outs of the Android model, which has some overlap with web and some overlap with traditional UI, and is just outside of my experience. In that specific case, yeah, there was no theory of code. There was no knowledge of what is in there. It was just the LLM sort of guessing its best and me guessing my best, which wasn't very good. And we did create something together, but something that will hopefully never have to be touched again. exact inverse experience is when I'm working on a code base I do understand and do know, and when that theory lives in my mind and I can direct the LLM to do what I want done just quite a bit faster. So I think this is really pointing towards continued, at least in with the current generation of product, and as far as any generation I've seen, somebody has to understand the code base holistically in order to direct the LLM to do something useful. And without that understanding, it quickly gets into a state where there is no theory, there is no basis. It's just an ad hoc collection of requests all jammed together by luck that are not causing conflicting errors with each other.
Thank you. I think Haipeng has his hand up for quite a while, so Sue, if you could wait for one.
Yeah, I really agree that we need to be cautious about the problem of getting into this terminally unmaintainable code bases. And personally, I feel if we don't have the directions properly, AI does amplify the problem of what that Rick mentioned, that it does the bare minimum exploration needed to get to exactly where it needs to change. And if the code base is inconsistent on doing something with two ways, AI will, in the good case, AI will pick one of these randomly, and in the worst case, it will make a third way to do the same thing. And it just makes the problem worse if we do not direct it appropriately and review the code. So I believe ultimately we are responsible for the code we commit, and in the code base that we know, we are responsible too for making sure that it doesn't introduce new fragmentation into the code. And another thing, I think we need to really want to invest in shared infrastructure, the instructions, the institutional guardrails. So there's this fascinating pull request in the Mom6 repository to include an agents.md. It's really well written. It doesn't just have coding style guidelines. It also has the considerations in the underlying design, the conventions of how the variables are named, how the arrays are structured, the performance considerations. And I even found it very educational to read as a human. And I think we want to invest on spending time writing out the why in the code bases so that AI doesn't repeatedly making mistakes that just violate the conventions that are established in the code, because it may not be able to infer it just based on exploration.
Okay, so I don't do my own coding so much anymore. Like I say, I have a group of great software engineers that I work with, and as I was chatting with one of them last week, he told me how when he asked an LLM to write a big chunk of code, it ends up being a real mess and impossible to debug, kind of like Rick was saying. He's found that if he gives it prompts in pieces and it does more shorter code at a time, then he can actually deal with it and debug. Now, my own interaction is, recently I was trying to make a figure for a proposal. I wanted it to look kind of like one in somebody else's journal paper, but I didn't want to plagiarize it. So I fed it first to the unpaid ChatGPT and asked it to make something similar. And I looked at what it gave me. It had totally wrong physics in it. And that's a case where, it really did lose the theory behind what it was generating. Okay, so I gave it to Copilot. It made stick figures, really looks stupid. So then I eventually got a decent looking figure with a paid GPT. But, it took several iterations to get something that even had correct physics in it.
There's one question online, and then your turn. Okay. So how well do we understand, maybe just me do not understand it, if a LLM or AI agent on overstepping or find reason itself to disregard the rule README that we set up for them? Because some people use agents to validate the other agent's work. Does this count as a validation, as rule might be modified? Sorry, I'm just reading it off here. That was from Xia.
I'll start since that's become the tradition. I think it's a good question. And my quick 2 cents on it is you have to treat these LLMs like toddlers. You give them instructions, they understand it as you're saying it, but the second they walk away, they start doing their own thing. And these LLMs continue to do that. So as I mentioned, these READMEs, they're hands off, read the README before you go, follow these standards. The longer the conversation goes on, if you guys have experience with this, the longer the conversation goes on, the more the LLM will start forgetting rules and it starts to do its own thing. So one of the things that I do to address the question is keep our conversations very short. Because when you first start and you're talking to this toddler, they're, yes, I understand, yes, I understand. And then once they go off, they forget your rules. So you have to restart the conversation, and then you have their attention. And then I guess my solution is restart the conversation often, check it, and say, hey, you're supposed to be reading the README. And Claude and most others will be very apologetic. Oh, you're absolutely right. I've diverged from your instructions. Okay, we'll get back on it. But again, once that conversation is long, it's too much context, and they forget and they drift. So restart your conversations as often as you can. That's my approach.
Anyone else? Otherwise, we move on to Bill's question.
No.
My question is sort of a follow-on on the previous question. In my experience as a software developer, the code that I produce is sort of one outcome, but the learning that I get from struggling and writing that code is probably actually at least as important of an outcome. And so my concern right now with where we are is what's happening with that learning process. I just saw a great little piece from someone named Margaret Ann Story who coined the term cognitive debt, sort of similar to technical debt, where technical debt is where we write code that we save some time up front, but it can come back to bite us later. Cognitive debt, the idea being similar, like we can get this code out quickly, but we're not producing that knowledge. And I'm curious if you all think that's a problem, and if so, do you have ways to address that we may not be learning as much that helps us in the long term?
I'll start since I feel like this dovetails with something else I had written in my prepared remarks. Yes, I think that's a real issue. I don't think it's new with AIs. It's just much more pronounced with AIs. I think many of us have had the experience in the last 15 years of being able to Google a problem and find your solution neatly written by somebody on Stack Overflow. And if you copy it and you paste it and it works, and you can walk away and be very happy that you no longer have to solve that problem. Now, you're likely going to take more from that interaction than you would from having an LLM generate 500 lines of code that you don't review. But the same sort of back and forth between learning and production still existed. So that said, none of the solutions are easy here. In some sense, we do need to restrain ourselves. Sometimes you have to do something the hard way. In order to maintain those skills, we have to consider ourselves and our professional development as being co-equal to our need to be productive at work, right? If everything is just monitoring the LLM and its output and sort of crossing your fingers and hoping it works and having ChatGPT verify Opus, it's going to be the day will come very soon where your own skills will languish to the point where you're not necessary in the loop. That said, this also comes with how do people hire? How are people going to be looking for software engineers really in the next 5, 10, or 15 years, as long as this product generation looks like it does now? I cannot account for what it looks like if we suddenly reach AGI and these things are smarter or truly smarter than a PhD, as they're constantly claimed to be right now. But assuming the technology doesn't advance yet another, logarithmic scale-sized jump, software engineers, at least the people that I've been looking for and how we've interviewed recently, we're focusing on problem solving in person, whiteboard problem solving, ability to describe how you think about a problem, how you go about solving the problem, that is more important than correct code generation. We're looking at somebody who can read code. Code debugging and code reading is a much more important skill than it ever was in the past, although it was always important in the past. I think it's a truism that writing code has always been a little bit easier than reading code, but we all need to sharpen those skills. And through reading code and actually understanding it, we are developing a skill set that is both owned by us and continuing to be important in this modern day, as well as communication, being able to clearly express what you want to say, what you need solved, create unambiguous instructions, both for instructing others, as well as for instructing the AI, as well as for documenting this sort of institutional knowledge that Rick talked about in his question. So all of this is important. We need to be mindful of maintaining our own skills, but also consider that some of those skills might shift, in this world where code production is yet an order of magnitude easier than it was 5 years ago.
Okay, so this room is filled with very experienced software engineers, and I'm sure everybody is rightly skeptical of what their LLM gives them and uses their own judgment on what is correct and what isn't. What concerns me is this current generation of students, and for exactly the reason you brought up, Bill, is that how are they going to learn what's right and what isn't? My example of building a figure with wrong physics in it, a student may not recognize that and you could be putting out all kinds of information that is incorrect, has wrong physics. And if nobody recognizes that, and if the professors these days don't have time to look at every little thing their students do and judge what is correct, what is done by AI, what isn't, I am concerned what the future could look like. I think it's going to take a lot of mentoring by people like you to get that generation of new students to be as smart and recognize what's wrong.
Thank you. Haipeng?
I also wanted to echo the other panelists' replies that the human factor is really important and what the future lies ahead. Personally, I feel like when AI fails, it is also a learning experience for me because I don't know if others have had this issue where you ask AI to try to debug a problem or solve something that's not working. And have you seen AI spiral? When it gets the answer right in the first time, it just gives you the answer. But when it doesn't know, then it keeps just rambling about this. This is the problem. Oh no, it's not a problem, but that's the problem, and just spirals. And I had this story from last week. Showing one of the limitations of AI, where like last Friday I was refactoring some code and there were two steps that I wanted to do. The first one was bit for bit with the CAM development run, and then the second run diverged at the 8th time step, and something was off by 10 to the minus 14 in a handful of grid points out of hundreds of thousands. And then I decided to give Claude the diff between the two commits. And after 30 minutes and hundreds of thousands of tokens later, it concluded that the code was functionally equivalent and there was a round-off error introduced from moving code across module boundaries, and this will lead to compilers generating different optimized code. It was very plausible. It always speaks with such authority. And on a good day, given that the difference was so close to float 64 epsilon that anyone could have accepted that and moved on. But as a human, I felt stubborn. I decided not to accept that. And I went in and grabbed GDB and found that an intermediate variable was off by a factor of 2. It was definitely not round off. It was small because the effect was small in the final computation, but the actual bug was a scaling bug that was definitely a factor of 2 and not just 10 to the minus 15. So Claude had all this information at its disposal. I gave it the entire code base, but it decided to not look further. It found a reasonable explanation. It gave it to me, and AI takes this path of least resistance, and humans sometimes don't. Some humans sometimes just smell that there could be a problem in here, and that is something I feel LMs do not do well at this point, and it's still important for humans to step in and think that using their domain knowledge or just the instinct that there is a bug in here and I need to drill more deeply into it.
Thanks very much, Damien.
I'm really glad to hear your story, that you looked into it further. Not seeing the code, it's maybe hard for me to know exactly what happened there, but I can't really imagine a reason why moving code across from one module to another would cause a floating point, imprecision or round off error. I had an experience not too long ago where someone used ChatGPT to analyze some code that I wrote, and I knew that the code had a problem, which is why I was actually discussing it with them. But what they were pointing out wasn't really related to the problem I was talking about. And it ended up wasting 2 hours of my time because I was trying to fix a constraint that it said I was violating, which when I finally went to the Fortran standard, there's no such constraint. So it's oftentimes not clear to me whether the net result is that AI is actually saving us time because it costs us time too.
Yeah, Jesse, go ahead. Or
so something that I've noticed going back to pull requests, if I look at a pull request that a human submitted, it's 10 to 50 lines of code. If I look at a pull request that AI generated, it's hundreds and hundreds. And I'm wondering how you guys approach the human solution to that. If you have software engineers who are using AI, how do we get back to that more reasonable commit?
Everybody's looking at me to follow the standard. Yeah, so my engineer, I remember this conversation. I was telling him how productive I am. I was like, I wrote all this amazing stuff and we're making such great success. And look at this little UI that it built for me to manage my QC of all my variables. I was just so excited about it. And then he's like, but Luke, writing, like the amount of code you write is not what's impressive. It's about what it does. And I'm like, darn it, I was excited about this cool thing that I built, but I went back and looked at the code and it was just thousands of lines of code. And I'm like, I couldn't explain all that, but what I was building was a toy. It wasn't something that was production, so I was a little bit sloppy with it, and I just let Claude do its thing, and then the thing worked, the website came up, and I was able to do QC on the data, and that was the end goal, is to do that, and it did that well. But my engineer telling me, like, the volume of code doesn't matter, so that's when I went back and looked at it, and it had all kinds of stuff that wasn't needed. It was doing, during the process of kind of interacting with and saying, no, I'd rather this be done this way, or I'd rather not have a separate function, or I'd rather break up this function. We iterate a few times. And what I found is that in its unit tests, it was building unit tests to confirm that the functions were deleted, for instance. So it would write these hundreds of lines to test that it successfully removed a function. And I'm like, Claude, why? And I asked, like, why the heck are you doing that? Oh, you're absolutely right, which it always says. And then, so yeah, it's more the story to say that, if something functions, good, but now go make sure that it's functioning the way you want it to function and make sure that it's doing things and it's not just wasting lines of code, because Claude loves to write tons and tons of code, not just with unit tests, but even like its functions. It'll have helper functions upon helper functions. And it's like, I never asked you to have this automated system that tries to interpret what time zone. Just pass it as an argument. The user knows what time zone they're in. So you don't need 25 helper functions to try to guess. And so that's something else that Claude does as well, is it'll write code, but it's doing so many guesses. It's trying to figure out things where you could just say, no, stop all that, take that from the command line argument, and reduce 500 lines of code. So that's just some stories on how we've experienced that and how we try to handle that. But.
All right, Haipeng has his hand up.
Yeah, I've had this exact scenario where Cloud Opus is very prone to over-engineering its solutions. And I saw a tip online where if you have a Dumber model review the code that Opus generated, like if you ask Sonnet to review it, then it will try to pick some of the things and say that this is too long and it could be shortened, and it will give more functional suggestions to shorten the size of the pull requests, because it's really prone to over-engineering things that cannot be reused, and it makes 100 lines of routine to do something that could have been 2 lines.
Yeah, I mean, this is just putting into relief something that we've all known in the discipline has existed. Code is a tool. It creates amazing capabilities, but it's also a liability. Every single line of code that you write and you ship is eventually something that you will have to service and think about. And even if it's perfect, your libraries may become imperfect. The compilers might not be perfect in the future, and you may yet have to revisit any given line of code in the future. So the more you ship, the more maintenance burden you are creating. Nevertheless, we're all shipping code every single day. That is, ultimately what we have to do. We're solving problems that weren't solved, and writing code is necessary to do that. I see, for myself in the space of infrastructure, it's even more acute. In a perfect world, they wouldn't need me. I'm not necessary. The science is important. What I do is I enable the science, I enable the team to move forward. But the more code I own, the more I have to revisit it and maintain it. So how does this come back to LLMs? When we get a large pull request, whether it is generated by an LLM or a well-meaning contributor, it is important that that pull request be backed with the mandate of this large amount of code is necessary in order to enable a critical feature, a critical ability that we did not previously have. If that pull request is not delivering value commensurate with the line count, then it needs to be re-engineered. That's true whether it comes from an LLM or a person. The only difference is we're seeing a lot more of them because LLMs make these large pull requests easier. We have a very large pull request right now, although that was generated within our team by a person carefully monitoring an LLM, spending nearly 250,000 tokens, a fairly expensive pull request. But that was also necessary. This had been on our roadmap for a while. So this is a case where a very large pull request is also delivering a very large amount of value. And all of this generated code was also very carefully watched by the person who was generating it. That's not always true. And the more external a contributor is, the less we know them, the more we're going to say, wait, hold on. Why was this the best way to do this? Why is this action necessary to move forward? Do we need what's being offered here? And is it worth our time to maintain this? Under the assumption that especially a third-party contributor may not be maintaining in the future. It'll ultimately come down to the project maintainers.
Thanks very much. All right.
I had a question, maybe more for you, Luke, since you're in the private industry. Have you seen any headwinds of, say, like stakeholders who maybe want you to be more efficient, so they push more of this and less of the human aspect? I know with UCAR it's a little different because we're strictly funded in a certain way, but if you're answering to someone else who's fitting the bill, have you hit any of these headwinds yet to be like, well, we appreciate this software, but we still want this human aspect? Have you seen any of that pushback or in any of the other companies that you may deal with?
That's a really good question, and one that I was looking forward to answering. I think in the private sector and in a lot of agencies that are, soft funded, especially RAL has the same problem. They have a lot of soft funding, so running efficiently is extremely important. It always has, and it always will be. And so I think right now for me in a startup, it's a little bit different than when I was at Tomorrow.io. We had bigger budgets. We could hire teams. I had 40 people. In a startup, I'm happy that we have these tools because it's not that I have the choice to hire, but if I did, and I will soon because we actually just raised some money, and so we're reviewing what hires we need, and we are going to be a little bit more conservative because we know that the one hire we make now, I'm not going to say 10x because a lot of people hate that, but they become more of a superhuman. They can be more productive, and you expect more productivity out of them, and so you expect to run more efficiently. That's really great for me in startup mode, but that cannot be what we do in perpetuity. Because if we do that and we say, hey, we can do all this stuff with only 5 people instead of 50, great, you can do that. But all the other companies and all the other agencies that are hiring additional people, and those people are empowered by LLMs, we're going to be left in the dust. So I think in the short term, a lot of companies are going to, and a lot of top level stakeholders, budget holders like me, I'm a budget holder in my company. Obviously, I want to run efficiently, but I also want to be strategic, and I want to beat our competition. And to do that, you can't run with 5 people just because it's cheap and they're massively productive, because our competition, they're going to hire like they always have, and those hires are going to be massively productive. So I think in the short term, we'll see a lot of the fear. A lot of people coming out of school are going to have a hard time finding jobs. But once companies realize this, that, okay, running efficient and saving money makes you at a massive disadvantage because you're no longer competitive. And so I think hiring will pick back up. But those people, the expectations are going to be different. Kind of going back to Bill's question about the importance of people knowing how to build the house from scratch. But I think we're asking our engineers not to be the lumberjack and the architect and the person building it and the person transporting the lumber. We're going to give them all that and say, just build a really damn good house. And so we're expecting them to build that house more, faster and more efficiently. But you can't come at the expense of just hiring fewer people.
Thank you.
Then a follow-up from the panel, then I will add something that Luke probably can relate to. If I'm working for the Navy, so the products we produce, the research goes into weather forecasts that are being pushed out to save our sailors and our assets at sea. And as you can imagine, on that operational side of things where we are cautious and conservative, thinking is a lot more pronounced as it is in the open world. You can't just throw LLM generated code out there and hope that it does the right thing when it matters. I said this yesterday to somebody. It's one thing if you get a forecast right in the public and the laundry is wet because it started to rain when we said it didn't. Then if you're trying to protect, assets, people, but that also extends to NOAA. So anyway, I was coming at Luke with that when you're working in an area where you have more security aspects and you need to be really, really careful, then you are naturally held back using these tools. So what the government has at its disposal is generations behind what the public can use in terms of which version of the models and what you're allowed to do with them. And so I see this gap opening up further and further and further, day by day, not month or year by year. It's day by day, because the public and the companies, they're forging ahead with new models and new capabilities and faster and whatnot. And we're losing out on our end. And then you have this gap that you have this more conservative traditional thinking where you need traditional software engineers who know how to code and all this kind of stuff. And then the Wild West, the world, the public world where everything moves ahead. So I was wondering if you could comment on that. Anybody here? Well, I guess, Luke, I'm looking at you.
I think that's interesting. I've heard similar things from a colleague in the Air Force, and there do have to be guardrails on things. Doesn't mean you can't use them. And in some sense, it's reassuring that the U.S. Department of War is being very careful with their use. One can imagine. I think we've all heard the horror stories of what could happen, and we want to avoid that. That doesn't mean that there aren't other countries out there using it. So I'm sure there's conversations happening at top levels on, to what extent do we use the LLMs and AI in smart ways? We do need guardrails, but how are we going to enforce that universally? And, these are hard questions that I'm not sure how we're going to answer.
Looks like nobody has the answer yet. We're coming up on time here, so I think this is a good time to wrap up. we can either ask one of the panelists to wrap up, or I can do it, or we can ask AI to wrap up, whatever. Anybody wants to take that on, or?
I'll go ahead and end where I started. There's a lot of productivity that we're gaining with the AI applications, but I think the summary of this panel is we still need smart humans overseeing everything. And, we can't trust it to get final solutions. The smart humans have to be in the loop.
And I think, I think these LLMs, AI support, it is here to stay. And I think we all need to adapt. I feel like I've done well enough. I'm almost 46, and I was hesitant. My engineer finally said, just get out of Jupyter Notebook, which is where I lived as a scientist, and start using VS Code and just get in there. And I'm like, I'm hesitant, but gosh, once I did it, it was amazing. And I think just the new generation that's coming out, the new engineers, the new scientists, they're going to have to know how to interview. And I saw a note over here, how I hire. And I would love to have heard that, but we are at a time. But how we hire is, one of the first questions we used to ask when I was at Tomorrow, I would ask them, do you use, AI? And 5 years ago, people were like, no, I hate it. I can't trust it. It's sloppy. But nowadays, it is getting better. It's making massive leaps, and it is really, really helpful, but you have to be cautious. So I think that for the new generation, they have to, and they don't have to, but I would recommend that they adopt it and learn how to extract value out of it, because companies, at least in the private sector, going back to the question, we're going to expect people to be more superhuman than they used to be. And that expectation's there. And our interview process is, how do you extract value from LLMs? It's not, do you use it or do you not? It's, you're going to use it if you work for us. And so how do you plan, and what's your experience on extracting value from it? But yeah, that's it.
I don't have anything to add. That was awesome. Yeah, I agree with everything you said.
All right, then I think the last word was Haiping.
Yeah, I also agree with what everyone else has said. And yeah, when we first had autocomplete in like the text editors, it was life-changing. You wouldn't type as much. And now with AI, it's the same thing. We still need people to oversee things, to have guardrails around how to use AI, and also incorporate it into our workflows, because it seems like it's here to stay.
Well, with that, I think we should thank our panel very much. This was a very interesting discussion, so thank you. Also, thank you to the audience for engaging. And I think we have a coffee break coming up. So if you want to, chat a little more, please enjoy coffee and sweets out there. And then we all reconvene at which time, Jesse? 10:20. All right. Thank you, everyone. All right. Welcome back, everyone. We're starting the second session of the morning, and the first talk is by Carol about using GitHub projects to manage software projects.
Okay, good morning, everyone. I'm Carol Ruchti. I'm a scientist at the Earth Observing Laboratory here at NCAR, and today I'm going to be talking about using GitHub projects to manage your software projects. I worked with a few different people to put this talk together, 3 other folks, Sarah Runkle, Janine Aquino, and Susan Stringer, and I'll talk about them here in a few slides. Okay, so what does software project management look like in your day-to-day? I would suggest all of you are doing some kind of software project management already. That would be creating GitHub issues. I assume most of you are already doing all of that. Attending different progress meetings if they happen monthly or weekly or bi-weekly. Maybe you're scheduling tasks for future projects, and you might even be using a project management tool. I think most people in this room are probably at least doing the first 2 items. Maybe you're not using a project management tool yet, but we're going to talk about some options today. Okay, so I just used AI to ask what are some common project management tools that folks use. I've only used Jira listed up here, but these 4 other, Trello, Monday.com, ClickUp, and Asana, maybe you all have used some of those before. I think these are great tools that could be used for your software project management, and they probably all have similar capabilities, Kanban boards, roadmaps, things like that. But it might be hard to integrate your GitHub issues directly into these. So what if there was a project management tool that was directly integrated into GitHub? Could that help with your project management? Could that help with your efficiency across your software teams? So I want to introduce GitHub Projects. Sits right in GitHub. It's an adaptable, flexible tool for planning and tracking your work on GitHub. I'm going to say this a lot. It's all in one place. You can see everything at one time. I think that's really the big advantage of using GitHub Projects that we've seen. You can add GitHub issues across multiple repositories. So for those of you that might be working in multiple repositories and it's hard to go back and forth across them, I think this is a great tool for you. It also has milestone tracking. It's, once again, similar features that are available in other project management tools are also available here. You can create individual project boards, various different custom views. I'll show you what that looks like here in a second, but you can have an individual map. You can have a map for a smaller project. You can have maps that show all of the recently completed issues, things like that. So yeah, you can have roadmaps. I think that was mentioned earlier this morning. Let's see what some of this will look like here in a second. So these are the 4 different folks that are using GitHub projects in my lab at the Earth Observing Laboratory. First, we have Sarah Runkle, who's a scientist at the Research Aviation Facility. She's really the one that has used GitHub projects the most, added a lot of automation for both creation of issues and creation of tasks within GitHub projects. And Sarah's really been key in trying to combine many repos into one GitHub project, since at the Research Aviation Facility, they work across tens of different repos. Susan Stringer works in my group in the Data Management and Services group, and she's a software engineer. And Susan Stringer was using GitHub projects back a few years ago when it was first created, and really using GitHub issues or GitHub projects to track her own work and share her work with various different team members at a very early stage of GitHub projects. And as I said, I'm a scientist and I also work in the Data Management and Services group. I'm more using GitHub projects as this high-level project management tool that's for our small team of maybe 4 to 5 people with only a few repos. I think we use maybe 3 at the most, so nothing quite as large scale as what Sarah has done. But I just think the display of GitHub projects really helps at our progress meetings, our monthly meetings, for quicker updates. And then Janine Aquino, she's a software engineer in the Research Aviation Facility working with Sarah, and she uses GitHub projects to manage all of her work. And Janine's been a really big advocate for the efficiency of working with GitHub projects to help the workflow of the software engineers at the RAF. Okay, so this is what it looks like. Hopefully this GitHub top level bar looks familiar to you all. This is a EOL field catalog GitHub project that I created. This is really basic. We have our issues. The issues are represented in all the boxes that you see there. And you simply just add the issue into the board here. And we have in progress, in review, and done. Something very simple, and honestly something that would just be a really good way to start using project management for your own projects, even if you just make this one board. There's also the done category. So the idea would be as soon as you close an issue, it goes into the done category. You can either manually do that or you can have that automatically set up within GitHub. And as I said before, it's all in one place. It's a quick look at the current status of your software project, and maybe you all have this in a different tool that you're using, but I think it is really useful to have it all here right in GitHub. Okay, so this is what it looks like to manually add an issue. At the bottom there, I'm trying to move the laser. Okay, at the bottom there, I'm searching for the GitHub repo and then searching for the issue that I want to add. And once you add the issue, it gets added into the in progress category on the left-hand side. And then once you click on the issue, it just pulls up all of the information that you would see for the issue. So once again, this is very transparent. It goes directly into the issue that you've already created. Then you can move that issue into in review, done, and all those other categories as well. So if you don't do anything else, I'm going to go into some more advanced things that you can do at GitHub projects. I think just creating this initial board of in review, in progress, and done can be a great starting place. Okay, so another example is a different kind of way that you can set up your view. This is a smaller project that Sarah has created with only 6 issues for a specific field campaign called Tiger 2 that's coming up. And you can see everyone that's been assigned very quickly to each of the issues. You can see the status as well of each of these 6 issues. And so if you have maybe a sprint or something and you're trying to say, let's get these 6 issues done in the next 2 weeks, you can create a board that very quickly has everything that you need. Once again, this is not, you know, groundbreaking or anything. You probably have this in other tools, but I think it is helpful to just have it right here in GitHub. Okay, so some advanced options that you can do with GitHub workflows. You can automatically add issues to your GitHub project from up to 5 repos. So you can see on the bottom, well, first of all, this is where you find the workflows in the upper right-hand corner of your GitHub project. Then you can add one of these default workflows that will automatically, if you choose a given repo, as soon as you create an issue, it will automatically go into GitHub projects. I think that option is really helpful. Some other options, like I just mentioned, no manual entry. What you can do, rather than doing what I just showed you in that video, you can have all the issues automatically appear in your GitHub project. And you can also set it up such that once you close the issue, it automatically goes into the done category. There is this limitation of only syncing 5 repos into one GitHub project, but I'll get to how you can get around that. You can add based on users, so you can use your GitHub group to automatically add repositories to your project if the group is added to it. So that's a great way to make sure that everyone within your group can see the project and see the repo. And then once again, this gives you a global view of the status of your teams all in one place, quickly access the issues that you've already spent time creating, and I think can be really efficient for your team. So if you do work across more than 5 repositories, you can create a custom workflow using the GitHub command line interface and schedule a cron job that can sync all of the issues across more than 5 repositories. I don't know the details of this. If you want to email me, I can get you in contact with Sarah. I'm sure you can use AI to figure this out too. But yeah, that's one way that you can get around the 5 repo limit. Okay, so if you have reoccurring issues or reoccurring tasks that you want to be added within GitHub, first of all, you can just create the GitHub issue within this cron job. So this is another thing that Sarah Runkle has created for RAF. In this case, on the right, what's created every month is a task for someone to check the backup of an archive. And so this is created for the March 2026 task. On the left, you can see what the example of the shell script looks like that's run within the cron job every month. And so if you have something like this where you need to check something every week, you need to check something every month, you can automatically have the issue created, assigned to the specific user, and then automatically added into the GitHub project. And I think this is really useful so that you can remember that you did the task that you're supposed to be doing, right? I think we have a lot of cognitive load to think of like, oh, did I check the archive? Did I not check the archive? Now it will be marked within GitHub and you'll be able to remember that you did complete the task. And also you're just not forgetting the task. It's automatically showing up without you having to do anything. Okay, so one thing that I think GitHub projects maybe lacks is this date syncing, or the idea of truly understanding when an issue has been opened and when an issue has been closed. Yes, you can open the issue manually and check when you open the issue and when you close the issue, but it doesn't come up very nicely within GitHub projects. But once again, Sarah has created a workaround with a different cron job that can be run such that you have, I know it's a little small on the screen here, but you have a start date in this column and you have an end date in this column. And so once you run this daily cron job, those outputs and attributes to each of the issues can then be displayed within GitHub projects. and this allows for easy tracking of achievements throughout the year, especially during performance evaluation time. So one thing that I think has been super helpful is structuring your meetings. I've now been leading our software team meetings for the last year or so, and I think it's been really helpful to, once again, all in one place, have these links directly back to the issues that were created. That creates a transparency of notes, and you can work directly within your GitHub project and directly within GitHub. Your software engineering meetings often require time to talk about your finished issues and the issues that are in progress and that have been stalled. And so if you can pull up that board really quickly, once again, you might have this board in a different tool that you already use, but if you can pull up that board, show your kind of roadmap and your status of things, that can make your meetings a little bit more efficient. And I think for supervisors and managers, now they don't necessarily have to wait for meetings to understand what your software engineers are working on. Granted, they have to take the time to actually look at the board, which maybe they don't necessarily do, but now they actually have the information that they might need to get an understanding of the status of your project. And finally, you can add project-specific milestones that allow your project managers to track your progress again. So like I was talking before, if you have a sprint or something, you can easily put that within your GitHub project to talk about the various different issues that you want to complete by a certain deadline. You can set up due dates for all of your issues as well within GitHub projects. Okay, we just got an email at NCAR talking about how our performance evaluations are starting up soon. I don't know if you all have to do pretty thorough performance evaluations for your organizations, but they do take a lot of time for us here at NCAR, and so we're hoping that using these logged issues within GitHub projects will be an excellent way to review all the work that we've completed within the last year. And it reduces our cognitive load and makes writing your performance evaluations more efficient. So to end with, how can software engineers do project management? I think yes. I think you're already doing it at some level. Maybe we can bump it up to a moderate level of project management if we add a few more of these tools available within GitHub projects. The easy integration into our well-known tool makes this transition easier, and I think it's a win for yourself to be able to log more of the work that you're doing, for your team to be able to see everything that's going on within the status of your software project, and also for your supervisors and managers to understand all the work that you're doing to complete your software project. So I hope this inspired you to think about maybe using GitHub projects in the future and start with something easy. I think creating that initial board should maybe take an hour of your time, maybe an afternoon, and could be really beneficial for your team. So happy to answer any questions. Thank you.
We have time for one quick question, and then we move on, please.
So you mentioned that sync date shell script. Is that something that is provided in GitHub projects, or is that something you guys custom wrote?
It's custom wrote, but if you email me, I'm happy to share it. Sarah wrote it. I'm sure she could share it. So,
okay, thank you.
Thanks.
All right, thanks again, Carol.
Thanks.
Next up is Julie talking about bridging documentation maintenance and collaboration in community scientific software.
Thank you.
Can we bring up the slides?
Yes, I'm trying to. I'm clicking on share settings, but nothing is happening. There we go. Sorry about that. I don't know exactly what I was doing wrong.
It's loading.
Okay. Does that look all right?
Yeah, perfect.
Okay, thank you so much. Good morning. My name is Julie Prestopnik. I'm a software engineer in NSF NCAR's Research Applications Lab in the Weather Intelligence and Security Program, and I also do work for the Developmental Testbed Center. I'm going to be talking to you today about bridging documentation, maintenance, and collaboration in community scientific software. I started working at RAL in 2004 as a student assistant, and I've worked on various projects over the years. I joined the MetPlus team back in 2012, the FastEddy team in 2024, and started working with the community software facility in 2025. I've learned a lot about community software over the years, some aspects of which I'll talk to you about today. Before I get started, I wanted to acknowledge the great teams that I work with. While the teams are larger than the colleagues that are listed here, these colleagues played a particularly large role in shaping the perspectives that I'll share with you today. So, I apologize, let me go back there. Okay, when we talk about scientific software, our minds may immediately think of algorithms or new features, and that's the visible peak of our work. But in reality, code is only a fraction of what makes the software functional over the long term. The true infrastructure, the part that keeps the ship afloat, is the maintenance and documentation that happens beneath the surface. Yet these are often treated as secondary or nice to have extras once the real work of coding is done. Ultimately, teams are dynamic, but software is long-lived. People move on, projects end, and institutional memories fade. When our processes for maintenance and collaboration remain implicit, located in the heads of a few developers, we aren't just being informal, we are creating points of failure. So to bridge the gap between a successful project and sustainable community tool, we have to stop treating these foundations as invisible. We need to make our workflows as explicit, repeatable, and visible as the science itself. Today, I'll share how we've transitioned from implicit knowledge to explicit infrastructure across projects like MET+ and FastEddy. This is what happens when the critical practices around a project remain implicit. The software might work well technically, but the operational knowledge isn't documented and is at risk. Releases may depend on one person who remembers the exact sequence of steps. Documentation slowly drifts away from reality because it isn't part of the workflow. Bug fixes get handled differently depending on who's available to fix them. And onboarding new contributors becomes slow because they have to reconstruct how things work. Individually, these may seem like small issues, but together they create a fragile infrastructure. And for community scientific software, where teams change over time and users depend on the result, that fragility becomes a real sustainability problem. So to ground this talk, I want to briefly share the context of the system where many of these ideas come from, MET+. MET+ is a community verification system that's been evolving for more than 17 years. It supports both research users and operational forecast centers, so we operate in an environment with real constraints around security, compatibility, and reproducibility. Over time, the software itself has grown significantly. MET+ started with one component only, MET. MET is one of the now 7 MET+ components and the core statistical engine. It started as a set of command line verification tools, primarily written in C++, and over the years, both the number of the tools and the complexity of workflows have expanded. What's just as interesting is how the processes around the software evolved alongside it. We've moved from using CVS to SVN to Git for software version control, from scheduled nightly testing using local shell scripts to enhancement-driven testing workflows triggered by GitHub Actions. From Word documentation to LaTeX to read the docs, and from basic security scanning to automated vulnerability scanning and code analysis. Each one of those changes solved a specific problem at the time, but taken together, they represent something bigger, the gradual construction of process infrastructure around the code. And that's really the framing for this talk. Sustainable community software isn't just about writing good code. It requires explicit documentation, repeatable maintenance processes, and collaborative workflows that survive beyond any single developer or team. One of the better practices that's made a real difference in MET+ is treating documentation as part of the software itself. Historically, documentation lived outside the repository in Word documents or LaTeX files and were easier to neglect. Over time, we've moved to a docs as code model, where documentation lives directly inside the repository, alongside the code in a docs directory. Today, our docs directory contains a contributor's guide, a release guide, a user's guide, and verification dataset documentation. Because the docs live with the code, they evolve together with the software. When a developer changes behavior or adds functionality, the documentation is right there and easier to update. We also enforce this culturally and technically. Our pull request template explicitly asks reviewers whether documentation updates are included. That question reinforces the expectation that code changes and documentation changes go together. On the automation side, documentation is built automatically. We use Sphinx and GitHub Actions workflows that run whenever documentation changes occur. The workflow builds the docs and fails if warnings or errors appear. That gives developers immediate feedback when something breaks in the documentation. And finally, Read the Docs integrates directly with all of the Met+ repositories and publishes the combined documentation through a single landing page. So for users, that means that the documentation for the entire system is accessible in one place. These practices turn documentation from something optional into part of the development infrastructure, and that makes collaboration much easier in community scientific software, where teams and contributors change over time. One example of developer-facing documentation that changed how our team thinks about documentation is the Met+ release guide. This guide isn't written for users, it's written for developers who cut the releases. At the beginning, it defines different release types: development releases, official releases, and bug fix releases. And that might sound simple, but explicitly defining those categories removes ambiguity about what processes we're following, and the steps are somewhat different depending on the release type. From there, the guide walks through step-by-step procedures for creating each release. There was some skepticism from our team about spending the time on creating a release guide. Maybe it felt pedantic or unnecessary, but we're scheduled to cut a beta release for Met at the end of this month. John Halligatway, the lead engineer on Met, will follow these instructions step by step. If he should be out unexpectedly as the backup lead, I would create the release, and I haven't created a release in many months. But because the process is written down, it's repeatable, and it's much easier for team members to backfill for each other. I might be concerned that I'd miss something if it weren't documented, but because the release process is clearly detailed, I have full confidence I can cut the release in the same way John would. Another thing that makes the guide sustainable is that we don't duplicate instructions everywhere. Instead, we store details about each step in the release steps directory and then include them in the correct order. In this list, the first 4 steps are common to all of the repositories, but the 5th step, about updating the version number, contains specific instructions that only apply to the Met repository. If you want a process to be repeatable, you have to write it down. That's how to move from relying on institutional memory to building reproducible project infrastructure. One of the things I've learned when working with Met+ is that maintenance can't be treated as informal work that happens when people have time. It has to be structured. In Met+, we organize development into 6-week cycles. Each cycle is managed through GitHub projects and milestones, so issues and pull requests are explicitly assigned to a development cycle. That means that maintenance tasks like bug fixes, compatibility updates, and documentation improvements show up in the same workflow as new features. Most every change goes through pull request review and automated continuous integration testing before it can be merged. Our GitHub Actions workflows build documentation, run unit tests and use cases, and compare results against truth data. That helps catch problems early and ensure that changes don't silently break scientific workflows. We also integrate code quality and security checks using tools like SonarQube. Pull requests that introduce new vulnerabilities or bugs should not be merged until those issues are addressed. The key idea here is that maintenance becomes visible and repeatable. Instead of relying on institutional memory or informal practices, the processes are encoded in the workflow, the continuous integration system, and the documentation. And that's what makes community scientific software sustainable, treating maintenance as infrastructure, not overhead. So one thing I learned from moving from Met+ to FastEddy is that not every practice transfers directly. Met+ is a mature community framework that's been evolving for over a decade. It has many repositories, a structured development cycle, and fairly formalized processes, which were developed iteratively over time. They did not start as complex as they are now, but they were expanded to include new enhancements as needed and as time and funding allowed. And those practices make sense for a large distributed project like Met+. But FastEddy is different. It's a younger project, historically internal to NCAR, and much smaller in scope. So applying the exact same structure would actually create unnecessary overhead. Instead, we've been thinking about practices in terms of scaling them to project maturity. For example, we adopted some foundational infrastructure fairly early. We consolidated repositories. We introduced docs as code with automated builds. We created a release workflow and set up a Slack workspace for collaboration. More recently, we've been building continuous integration for HPC testing, which compiles the model, runs jobs through the scheduler, and performs regression tests against reference data. But other things remain intentionally lightweight. For instance, development planning is still largely managed through a shared spreadsheet rather than a more complex issue tracking system, and that works well for the current team size. This aligns closely with a tiered approach to scientific software quality. Smaller or earlier stage projects benefit from simpler processes, and rigor increases as the project grows. So the key takeaway is that sustainable practices are not one size fits all. The goal isn't to copy processes from another project, but rather to adapt them so that they fit the project's scale, team, and stage of development. Another effort that has started to intersect with this work is the Community Software Facility. The CSF is a center-level initiative at NSF-NCAR focused on modernizing how we develop, support, and sustain community models in scientific software. The goals include improving governance for community software, developing shared development practices, supporting training for software engineers, and helping projects adapt to things like heterogeneous computing architectures, CI/CD, and emerging technologies. I started working with the CSF at the end of last year, and one of the efforts that's now getting underway is the Better Practice Initiative. What's important here is that it's not about introducing a fixed set of standards or a top-down requirements. The goal is to work collaboratively with projects to identify practices that are already effective, make them visible, and make them easier to adopt and sustain. One mechanism being discussed is a code audit or project review process. The focus is not on evaluating individuals, but on examining the project itself, its workflows, documentation, testing, and release processes. And really, that's the connection to everything I've talked about today. When documentation, maintenance, and collaboration are treated as shared infrastructure, something we design intentionally rather than inherit implicitly, we make our software more reproducible, more transferable, and more sustainable. The CSF is one way NSF-NCAR is trying to make that shift explicit by turning what is often informal and project-specific into something that can be shared, adapted, and improved across the community. What I want to leave you with today is that sustainability in community software is not a separate effort. It's the output of making processes explicit and routine. In MET+, what made the biggest difference wasn't a single tool or policy. It was treating the documentation and maintenance as infrastructure, something we build, maintain, and rely on every day. By writing procedures down, we traded ambiguity for reproducibility. Automating routine checks made quality and compatibility part of the workflow, not an afterthought. Ultimately, these practices make collaboration easier across teams because expectations and processes were visible instead of implicit. So it's not about adding more work, but rather about making the work you're already doing more consistent, more shareable, and more sustainable over time. Thank you. I'm happy to take any questions if we have time.
Yeah, thanks very much, Julie. We have time for a couple of questions. There are none in the room, so I'll ask one. Another approach to, you said if you want something to be repeatable, you have to write it down. Another approach is to automate it. That's even more reliable than writing it down. And that lends itself to a more agile development approach where you click a button and then the entire release is done automatically and you don't even need to think about it anymore. Can you comment on that, please?
Yes, absolutely. I completely agree. I think continuous integration is certainly part of it. One thing that was mentioned earlier in Carol's GitHub projects tool is, I'm sorry, her talk was how GitHub projects can be helpful for performance evaluations, for example. We use it in the creation of our release notes. Our issues are titled such that they're just, that's what we use for our release notes, and we post links to the issue in our release notes. So automation can be helpful for things like that. There are some things I would say that automation can't do. For example, we have to update our development testbed center with through Drupal with our release information. So some things in that sense are added extras that can't be done through GitHub projects, for example, or through continuous integration. So I guess it depends on the needs for your project. I definitely would advocate for putting as much in continuous integration as possible so that it's documented there. It's both documented and able to run by itself.
Great. Thanks very much.
Thank you.
Okay, Jesse, one more quick question. Go ahead.
Hey, thanks, Julia. I don't know how quick this is going to be, but you mentioned in your documentation, and you kind of mentioned users guides, which I imagine is describing how to use the software, and then kind of developer guide to how do you develop the software. But do you also have, because one thing we struggle with is kind of like scientific documentation, where it's like a scientist will describe the actual algorithm or the math or whatever that's being done. So I guess, do you have that? And then and if you do have that kind of documentation, how is that incorporated into your system? Like, how do you get the scientists to make sure they're contributing to this documentation?
Yeah, I would say that that's part of our pull request template is that we ask if documentation is included, and often we have both a scientist and engineer review the pull request. So who's ever reviewing the pull request, if they don't feel that the documentation is up to par for their needs, then they'll say so, and we'll ask the scientist to add some further information about what needs to be done. There are definitely plenty of gaps here. We utilize GitHub discussions for user support, and often we'll have a user write and say, hey, I don't really understand what's happening here. And so we'll respond with a lengthy answer, but then we'll also take it as an opportunity to enhance our documentation with the information that we wrote to the user. So even if it's technical, that information is also contained in the user's guide for those who want to understand what's going on behind the scenes. I would say that over the years, maybe we didn't pursue that method. So there's a lot of adding on in that area now, but it can be done. Or if you were to go look at the Met Plus users guide, it's very lengthy. I'm not sure how long. It could be 1,000 pages when it's converted to PDF. So it's long, but GitHub and being in Read the Docs, it allows you to search to find what you need. So it can be easier than, a PDF. I mean, you can search through the PDF, but at least, you'll get multiple results when you search for something and Read the Docs. So yeah, it's just lengthy, having been around for 17 years plus. But we do try to add that documentation for users who want that level of technical detail.
Well, awesome. Thanks.
Thank you.
All right. Thank you very much. So next up is Primus talking about documentation as infrastructure, a practical framework for sustainable scientific software.
Hello, everyone. I am Primus. And first, I want to say that whoever arranged today's talks did a really good job, because the two people who have talked before me actually are in line with what I'm going to be talking about. So let's get to it. All right. So as some of you know and some of you don't, I am Primus, and I'm from Purdue University's Rosen Center for Advanced Computing. And my talk is going to be on documentation as infrastructure. Now, those who have already talked before me and myself, we are beginning to rethink documentation not as an afterthought, but rather as infrastructure. And so if you look here, we have what I call the infrastructure mindset. Docs need ownership, structure, and maintenance. And also, there is the need for centralized knowledge, which provides a single source of truth across all the teams. And finally, we have what I call the practical framework, which are the three pillars that I consider for documentation as infrastructure, which will be governance, structure, and tooling. And finally, this will produce a sustainable design, which is built to evolve and not to rot. So then, what is the problem? What are we trying to solve? The problem is documentation depth. So scientific software doesn't fail because of code. Mostly it fails because of knowledge loss. And this is a big problem. So maybe the understanding of a certain implementation or certain application lives in the memory of one or two core developers. And when you bring on someone new, they are basically lost. Or if the people who were the foundations of that application are not there, then it becomes a problem. And then you have what I call tangled documentations. Onboarding takes weeks. I've experienced that. Duplication occurs across several teams, and then there's inconsistent practices. And so team A does this is how we do our work, and team B does this, and this is how we do our work. And when you try to bring those together, it becomes inconsistent because you don't have like one standard practice. And then finally, you have knowledge silos. And now if you go through sustainable documentation, your onboarding becomes fast and structured. You have a single source of truth, and you can always point to it, and the information will be current and accurate. And the standards will become consistent, and knowledge continues to evolve instead of getting left behind. All right, so here's a real example. One of those scenarios I said I had experienced. So we are trying to onboard a new graduate student to join our HPC project. And we have documentation scattered all over the place. Some even live in emails. And so there's no single entry point. And you end up having, so in this scenario, I point out week 3, where the student finally becomes productive. But we've also had occasions where it took more than that for them to become productive. So in the end, the cost becomes 3 weeks of lost productivity, and it keeps repeating across every new team member that you add, not just students, but also developers as well. So what is the fix? Treat documentation as infrastructure, not as afterthought. So treating documentation as infrastructure will be the same way we treat compute, the same way we treat storage. We should also treat documentation in that same way. So something that needs to be designed, something that needs ownership, something that needs to be maintained. And once you have that mind shift, everything else becomes easier. So then, why does centralization matter, you would ask? Before that, if you look on this point, you see scattered documentations. You have wikis live over there, README in some other places, email threads of maybe someone asked a question and then the reply was given by an email, but it didn't get to other team members. You have slide decks, you have local notes, Google Notes, etc. But if you centralize your information and treat documentation as infrastructure, you will have a unified hub, and there will be a single source of truth. So that will reduce your fragmentation, that will support reproducibility, and it will scale across different teams and in some cases different institutions. Well then, let us consider the 3 pillars I mentioned earlier for sustainable documentation in scientific software teams. One of them, as I said before, was ownership. So when documentation doesn't have ownership, it causes decay. And so we have to define who the maintainers are, who the contributors are, and also we have to have some kind of governance. It doesn't have to be heavy. Lightweight is okay. Now, let us look at also structure. Structure and architecture is one of the 3 pillars of sustainable documentation. And what would that be? We would have templates, we would have naming conventions, and it will also make it contributor friendly. I think these are the 3 things I have seen across commercial software and research software that have made the difference. So commercial software have all these things listed out in those organizations and how to follow them and what to do. But most of the time, because of the time constraints of research software, we don't really tend to think about these things. We just want to push the application out fast. And then tooling. Tooling is quite important, like we just said. Automating as much as you can is good, and having all those CI checks and versioning creates efficiency. So let's talk about those. Pillar 1, ownership and governance. So as you can see from this table, we have different roles and we have different responsibilities assigned to those roles. So there will be the one who maintains the documentation. He will be responsible for for that. He will have accountability for how the documentation progresses, whether it evolves or not. And then we have contributor. He will also be responsible for the documentation as well. But if changes are being made, they would have to be consulted, or they will have to consult someone to make those changes. Then the team lead, as you can see here, has like all these roles as well. So to cut the time short, if you can take a look at this table, and so let's carry on. Let's go to pillar 2, structure and information. So when you create a structure, like the previous speaker before me showed something similar, you design for the documentation to be contributed to. So you have templates that are standardized across your projects. You would have naming conventions that will create predictable file names and folder names. And so when you see this file name and this folder name, you know it belongs to this place and not to that place. And then it would also reduce the cognitive load for new developers, and it will help them easily identify what they're doing and where they're going to put what. So the layout will become contributor friendly. So there is something called contributing.md, which is a document that you can come across in several documentations, but it should not be treated as an afterthought. Rather, it should be treated as the first level of documentation as infrastructure. Now, moving on, let's look at tooling. So I'm sure everyone here has been using different kinds of tools to do their work. GitHub is a very good place as well. The people who have talked before me, they've talked about projects and stuff, depending on what your organization is using. So I'm not here to say, hey, use this tool or use that. But whatever tool you're using, I want you to think of documentation as infrastructure, as essential to whatever tool it is you're going to be using. So your commits, your CI checks, your doc builds, your link checks, and your deployment, you should always think of them as important. So when you automate all these things, you have less broken links, you have style consistency, and your versioning becomes automated. So this will remove the manual burden, and it will keep your documentation healthy over time. And so the burden of keeping your documentation up to date becomes reduced. Now, here's a case study, a few of the projects that we used to test this framework out. So we have an application called Halcyon, which we use for managing our HPC clusters. And we tried this out on Halcyon as well. So what worked for us, we were able to centralize our module documentations. At first, there was resistance to adoption. But after that, we found that our tickets that were being submitted reduced because we were able to get to problems and issues faster. Now, another project that we did that on is called Cyberfaces. And Cyberfaces is a learning platform for cyber training for geospatial I forget what the other word is, but it's for geospatial training. And we were able to create templates that those who are uploading content to the platform were able to follow. And so it kept all those information consistent. But we do have version drift in the tutorials. Like one of the recent ones we have is trying to onboard new people, and they want to bring their own style into it. And so in trying to satisfy their demands, we're thinking, okay, should we change how we do things? So that is one of the things that didn't work because we're trying to get more people in. We're thinking, okay, maybe we should just do whatever they want. But the thing that worked and the surprise for us was that across the team, the pattern was reused and repeated. Now we have internal HPC workflows, and the governance model has worked for us. The automation setup is a problem for the internal HPC workflows because there are several teams touching the workflow, and some of them are already, rooted in their in their standards and they don't want to change, so they are resisting change, just like we saw with the Halcyon models. But we're able to see that teams were able, the ones that adopted, they were able to self-organize fast. Now, the lessons we've learned from this is that we should start with structure. If we start with the structure, then it becomes the standard, and not everyone do whatever you want, and then later down the line we'll fix the problem. One size does not fit all. Depending on what they are working on, you would have to adapt this the framework to suit their needs. And so, in essence, we found that culture sometimes defeats tooling. And so that is something important you have to take note of. So if you start with the structure, then you will be able to at least overcome the culture before it starts. All right. So now we had a lot of talks about AI. So where does AI come into this? How does AI get to help? So yesterday, while I was reviewing my material and during the AI talks, I did encounter, I think it was from Sean Paulson. He did a talk on the Claude skills that he had done. And I realized that I haven't used AI for this. And I decided to give it a try. So I spoke with him, and then I gave it a try. So I uploaded my framework to Claude, and I said, hey, give me a Claude skill based on this document. And it did give me a Claude skill. I haven't tested it out yet, but reading through it, it did seem plausible. So maybe it's something to look into. But getting back to the topic. So where does AI come in? Use AI for these, summarizing long documents. So that would be helpful. Refactoring verbose writing. So maybe the writing could be broken down further. AI would help you break it down. Drafting onboarding guides, that could also help. And generating documentation stubs or suggesting structure improvement where necessary. Avoid these, domain-specific technical accuracy. So like we know, most of the AIs have been trained on general knowledge. And so domain-specific knowledge will be a problem for them. So try to avoid them unless you have created your own model that is trained particularly on that knowledge. Now, scientific fact verification is also something that you have to avoid. But if you decide to use AI for it, make sure a human verifies it. Also, there are some topics that are prone to hallucination. So try to avoid using AI for those. Now, regulatory and compliance documentation, that like what we had in the panel talks, there are some documents that you don't want the AI to modify. So try to avoid letting the AI modify those files. And then the final review. So whatever the AI helps you with, always review it. So here's a startup plan. This was how we started, and you could also adopt this if you wanted to. There's the audits. Week 2, you look at the structures. Week 3, you look at governance, and then automate. So if you look at this information, I'm just going to run through it quickly without, you map all your existing documentations. Where are they? In what format are they in? And all of that. You bring them all together. You find the ones that have been duplicated because they live in different places. There might be duplicates. Try to identify all the gaps and then survey the team. What does the team think about this? What do they say? Then you move on to structure. You choose a platform. What platform do you want your documentation to live in perpetuity? You define your folder layouts, you create your documentation templates, and then how you're going to style them. And week 3, as a note, I'm not saying this has to be done in 4 weeks. You can do it as long as you want. You can do it in 1 day if you had a small enough team, or however you want to do it. But this is how we started. So you look at governance. You assign your maintainers. Like you saw me show you earlier about the roles. So documentation, maintenance, contributors, and all of that. You assign those to people, and then those people have the responsibility of fulfilling those tasks. Changes are made, who takes responsibility for that? and so on. And then you automate whatever CI pipeline you want to use to run this. Try as much as you can to automate it. Automation does save you a lot of overhead and also the mental load as well. Now, the key takeaways here. Documentation is infrastructure. You remember before I said documentation as infrastructure, but now I want you to take away that documentation is infrastructure. So treat it as a shared system with ownership, structure, and maintenance, not a side task. And also centralization reduces depth. So a single source of truth will eliminate fragmentation and speed up your onboarding processes. Sustainable documentation equals producibility. So well-maintained documentation directly supports scientific reproducibility. That way your application or your research doesn't die, right? And then start small and iterate. So maybe take one project, take one process, and start with that. And then iterate as you go. As you see that work in one, you move on to the next one. So pick one pillar, whichever one it is, audit first, build incrementally, and don't boil the ocean. I mean, you wouldn't succeed at it. But finally, I want to thank you all. And if anybody would like to collaborate with me or with my team, our contact and information is available, Purdue ucar-sea. You would always get to us. Thank you so much.
Thank you, Primus. Questions?
You kind of briefly touched on it in your talk about versioning of the documentation. The problem that we struggle with is that if the documentation lives in the code, the versioning of the code doesn't necessarily mimic what the versioning of the documentation is that you're having. So for HTTP5, for example, we had 4 branches that were active. You had to keep the documentation in sync with, and it's all in Doxygen. So what we decided to do was we have one source of documentation and bake in which version. So for example, an API was introduced in this particular version, right? Mm-hmm. So we don't have APIs associated with a certain release version of the documentation. Could you comment on that aspect of having the documentation live in the code in terms of versioning?
Yeah, so we did face that challenge. The projects we've worked on were initially created that way. Documentation lived in the code. But when we were trying to create this framework, what we did was, because we have most of our processes are APIs, so we decided to use the APIs for the forward-facing or the user-facing part of the documentation, and then the developer-facing part of the documentation still remained in the code. And so the developer had the responsibility of, okay, when I push my code to the first branch, because we don't push directly to the deployed or the production. So when you push it there, then someone has to take a look at it and see if they understood exactly what you were saying in the documentation, the new information you had added to it, and see if it did exactly what you said it did. And if it did, then approved, and then it moves on and on. So that was how we did that. Yeah, like you said, that is a big challenge. And so tackle it in 2 ways, right? The user-facing part of the documentation, keep it as current as possible using these frameworks, and then the developer part of the documentation, following your processes, try to make sure that this information is as up to date as possible.
Hi all, welcome back to the afternoon session of the Improving Scientific Software Conference. This is going to be our first tutorial session, which will be presented by Carol Ruchti, Jenny Knuth, and Bhagyashree Waghule on rapid usability testing. And go ahead, take it away whenever you're ready.
Okay, testing, yeah, great. And you can go ahead and fill out the welcome survey that's up here. We're going to introduce ourselves and tell you a little bit about how the tutorial is going to work. So my name's Jenny Knuth. I'm a front-end web developer at LASP, and I make space weather applications. Carol?
Hello, everyone. Again, I'm Carol Ruchti. I'm a scientist at the Earth Observing Laboratory. I recently did a usability test with a few people for a tool that I manage called the Field Catalog. So thanks to Jenny for inviting me to be part of this tutorial.
Hi, and I'm Bhagyashree Waghule. I'm a postdoctoral associate at CU Boulder, and I use a lot of data.
And we're here because we're interested in improving scientific software, and an effective but often overlooked way to do that is through usability testing. We often talk about the coding, but also our users are very important. So this content has been developed with the support from the Sloan Foundation as part of the Strudel project, and we've adopted a carpentries model to deliver the content and are hoping to share this as a resource that you can use on your own time in the near future. This is the alpha version, and your feedback will be important to improving the curriculum. So please respond to the welcome survey. You'll find a link and a QR code on the Google Doc. So the goals are to teach you to identify scenarios and tasks appropriate for rapid usability testing, how to recruit for a user study and track participant data, how to conduct a rapid usability assessment and analyze the results. And the tutorial is broken up into 5 episodes. We'll have a 5-minute break about halfway through. And it's structured so that there are lots of exercises and examples to keep you engaged and to deliver the bulk of the information. We'll use Qualtrics surveys like this welcome survey to do the exercises. And you might want somewhere to jot down notes when we're doing exercises. And then we'll use public software projects as examples, but many of you, as I know, have software projects of your own. So it might be helpful to keep those in mind as we go through the exercises. And rather than slides, we'll be sharing a Google Doc with the important content. And you'll have, in addition to the doc being shared on the screen, you can also open up the doc and follow along, but you don't need to read it. You'll have access to the doc after the training, so you can reference it later. You can save the link or download it or however you like to do that. And each section will start with questions and learning objectives, and the episode will, that the episode will address, and we'll end with some key points. And these are shared via text for your benefit later, but I'm not going to read through those. They'll get covered in the body of the episode. So if you're on the doc on your computer, if it's not already, you can set it to pageless format. And then if in the middle of an episode you have questions that need immediate attention, you can put them in the chat, and Bhagyashree or Carol will help answer them or ask it aloud. And then after our exercises, we'll have some discussion so people can ask their questions then as well. Let's see, what else? Want to make sure, oh yeah, keep your mic muted if you're not in a breakout room or called on to speak. Any questions so far? All right.
Yes.
Oh, sorry, yes.
Where do you find this doc?
Sorry, Bhagyashree, can you put the link in the chat? So we will do that.
And where do I find the chat?
Who aren't on the Zoom. Okay, so there is a short URL listed there. Is that too much to type in?
No.
So, sorry, yes. You don't have to be on the Zoom to experience this tutorial.
I will be presenting the Google Doc, so hopefully you'll be able to follow along on the screen as well. But if you want to open this document yourself, you can follow the link that I just highlighted.
Yeah, there are links in the doc as well, so it's good to have a reference for it. You got on? Okay. I can slow down. Thank you. Excellent, excellent question. Okay, and I hope you've had time to fill out the welcome survey. We can maybe look at some of the results and just see. I was also going to ask, I didn't talk about the ucar-sea UX working group, which is UX in this case stands for user experience, because I learned about UX array yesterday, but that's UX array. So if we're talking about UX, it's user experience in this context. Okay, so let's see. Oh, that's fine. So yeah, let's just see what some people are up to. So we got a lot of software engineers, as we would expect, and lots of different fields, which is very exciting. And most people are not at all confident about conducting a rapid usability test, and some people are likely or somewhat likely to conduct one on the job. That's great. Okay, so we'll start with episode 1. And we'll define, recognize, and identify rapid usability testing. So what is usability? User experience research, or UXR, is the investigation of how people interact with, make sense of, and respond to technology and services. Often, your goal with UXR will be to improve the usability of your product, making it easier to adopt and use. Usability is made up of other attributes that determine how easy it is to use a technology or service, and the Nielsen-Norman Group is a respected authority on usability and user research, and they've identified several characteristics of usability that are lightly adapted here. First, there's learnability. How easy is it for users to accomplish basic tasks the first time they encounter the design? Efficiency. Once users have learned the design, how quickly can they perform tasks? Memorability. When users return to the design after a period of not using it, how easily can they reestablish proficiency? Errors. How many errors do users make? How severe are those errors? And how easily can they recover from the errors? User satisfaction. How pleasant is it to use the design? How positive or negative are users' feelings about the tool? And finally, utility. Does it do what users need? Does it enable users to accomplish their goals? All right, we'll start with exercise 1, which will be a skit. So in this skit, you'll watch a study facilitator guides a participant through a rapid usability test. So for the purposes of this tutorial, you have the view a participant would. And this means that you can see the participant's screen when the facilitator would as they complete a task. And also at times, you can see the user screen when the facilitator would not be able to as they reply to a survey, because that's important that they can have privacy when they answer questions. So after the skit is over, we'll discuss the skit as a group and think about what was interesting to you, what was confusing, or what aspects of usability do you think this study could address. So you're all watching as if you were a participant, and Bhagyashree, I'll just start. So Bhagyashree, thanks for joining me today. I'm Jenny, and I'll be guiding you through the study session. We're here to try and find ways we can improve the Strudel website. Just to assure you, this is not a test of your abilities. We're here to evaluate the website, not you. So during the session, I'll assign you a task to complete on the Strudel website, and then I'll have a survey question for you.
Okay, sounds good.
Okay, I sent you the informed consent information over email. Did you have any questions about that?
I saw that, no questions.
Great. Do I have permission to record this session then? You might want to minimize any open applications.
Okay, nothing's open.
All right. So the recording has started. To set up for the task I'll assign you, you can start sharing your screen so I can observe what you do on the website. Do you need to stop sharing? Or? Okay, and we want to be able to observe, what you do. So let me know when you're ready. Oh, you are sharing your screen, great.
I'm sharing my screen.
Okay, so in just a second, I will chat you the link to the Strudel website. And here's the scenario. You're starting on a research software project, and your team has been told to, quote, keep the user experience in mind, but no one on the team has UX experience. So you've come across this website, and you want to figure out whether it can help you get started. So while you're exploring the site, please narrate your thoughts and actions so that I can hear what you are thinking. Any questions?
Nope, good to go.
Okay, here's the link. And I'm not on the Zoom, actually, so do you have the link handy? It's strudel.science is the link. And your task is to find on this site one concrete thing that you could realistically use to improve your project. Great. Yeah, it's coming up. Thank you.
Okay, great. So here's the Strudel website. I legit have never seen this before. Okay, so let's see. It looks like there's a bunch of different options up top here, including the training planning, design systems, galleries, so on. So let's go into the design system. That looks interesting. Let's see, in here, there seems to be a bunch of different options, how to use the system, and so on. would be great to see if there's any examples, because this is a little too dense for me. Let's see, gallery. Okay, so in gallery, it seems like they have various different examples of how this has been used, or for what purposes this has been used in the past. Okay, great. Let's see, there's about, engage. Okay, it definitely looks like there's a lot more to explore in task flows. Okay, explore task flows. Ooh, browse flows.
Okay, I'm going to stop you there. That's as far as you need to go in the task for now. And you can stop sharing your screen, but don't actually stop sharing your screen. So here's a link to a survey question I have for you about the task. And the survey will ask for a participant ID. Your ID is P4. And just let me know when you're done with that survey.
Carol, can you paste that in the chat? Okay, so you said P4, and then how confident am I in the resources? I'm just going to go with 3, very neutral, and submit. Great.
Great, that's all I have for you today. Do you have any questions for me?
Nope.
All right, well, thank you for participating. I hope you enjoy the rest of your day. All right. Okay. Excellent. All right. So Carol can go back to sharing the doc, and let's talk about that. So I guess it's a little hard with people online as well as hybrid, but what was interesting to you? What was confusing? What aspects of usability do you think this study could address?
So the first thing that occurred to me was some kind of like a where to get started, or, you know, how to use this website kind of a thing. You just jumped right in and went all over the place. And for me, I would have been like, how do I use this? And so, yeah, I don't know if that's you know, if that was more prominent to help somebody guide them to, if you're new to this site, you know what I mean? Because I was just, how do you even begin with all this content? It was very, very dense.
Yeah, so we'll review that later, like what you should do in a usability test, and how silence can actually be really helpful sometimes.
Okay.
So I don't know whether this was just intent because of the time frame we've got, but that felt like a very, very short time between when you introduced the site and you asked her to evaluate it.
Yes, that is accurate. That it is because we're doing a workshop, not an actual usability test, but you also don't want to have them drag on or take too much time, and you want to test a real world situation.
So what would be the time frame for a website like
Yeah, we'll get into that. So perfect question. Excellent question.
There's also a comment online from Sam Rabin mentioning determine the different ways people browse your website from the landing page. So yeah, I think that was a good example here of just showing someone a website for the first time and seeing how they react.
Yeah, it's good to get just overall impressions of your website if it's something that's important to your research questions. So, all right. There's many methods to study user experiences. You could do interviews, observation, participatory design, A/B testing, surveys, contextual inquiry, card sorting, many more options. But rapid usability testing is a kind of user research that focuses on how a small number of users interact with specific software, technology, or service. It evaluates the experience. Rapid usability testing is meant to help you make decisions about how to design your tool and user experience. It's not academic level rigor. It's meant to be quick and good enough to make informed decisions. So you may wish to use rapidability testing in order to compare user populations or design options. Do people prefer X or Y? In my experience, you might find sometimes that neither design option is good, but if you have follow-up interview questions, you can learn why and still integrate some improvements into your code quickly. So in a testing session, a researcher will ask a participant to perform a series of tasks or respond to a set of prepared prompts related to the tool being tested. And these tasks should be well scoped. This makes them quick to accomplish and easy to interpret results. So you could argue that the task might not have been as well scoped as it could have been. The researcher will observe their behavior, may ask them to think aloud as they perform the task, and will ask follow-up questions when necessary. And you probably just want to involve 3 to 5 people. Because usability tests are used to assess some interface and offer insights, this means you must have something for users to work with during the test. So that could be a tool or service already available for use, or you can create an interactive prototype using tools designed for this purpose, such as Balsamiq or Figma. Or maybe you have a paper prototype for people to interact with. Whatever you have doesn't have to be a final product or perfect, but you do need something for users to interact with. So this is exercise 2, again, a Qualtrics survey. When should rapid usability testing be used? So you can go to is it pasted? The link, and answer these questions. I can read them out loud, actually. So for each of the scenarios below, consider if the person in each scenario should start rapid usability testing next. Indicate your decision in the survey link and jot down some notes if you choose. So Ray is going to develop a gold standard data set of journal article submissions tagged with their venues, peer review outcomes, and reasons for acceptance or rejection. Ray will develop a tool that assesses draft articles for their probability of successful publication. Chung previously made their software package Fancy available via downloads on their personal website. Users could install the downloaded files. Chung recently made Fancy installable with the pip package management system, but he's gotten a bunch of emails from users having trouble with pip. And Sam wrote a script that helps 2 lab mates automate some common tasks. Sam was thinking the script might be more useful if it also logged in a shared spreadsheet when it was executed and by whom. So just take a second to complete that. I think there's a delay on the results as well, so I'm not sure how well they'll show up if we look at the results of this survey. There's nothing, yeah, it might be on a delay. But we can just go through the answers. You might refresh in a few minutes. But so for Ray, it's probably too early to begin a usability test. Like there isn't something to test. But if she had something or they had something to actually test, it would be fine. What did people say for Chung? Anybody want to volunteer? Yes, go for it. Yes. So Chung is ready to go. And what about Sam? Any opinions on Sam? Not so much. Yeah. Yeah, it seems like it's a pretty small group of people who are going to be using this tool, and maybe not enough, but you know, he could definitely do some work as well. Oh, I'm sorry. Okay, great. Do you want to refresh and see if anybody's, yeah. There was a lot of text. Thank you. No? Okay. I think there's quite a delay on this Qualtrics, but fine. All right, well, you'll have the questions and the answer key in the document in the end, so we're just, yeah, we can move on. So any other questions before we wrap up this episode? So rapid usability testing is one of many approaches in UXR. There are a variety of methods which may be better suited for different scenarios, circumstances, or phases of the product life cycle. For example, user discovery sessions may be a good fit for when a general concept is known, but an associated tool or service doesn't exist yet. Like, for example, you know, if you're going to do a search tool, you could ask people, what search tools do you already use? What do you like about them? What pain points do you experience? Affinity diagramming is an approach that's particularly well suited for the qualitative analysis of user feedback with smaller sample sizes. And so there's some resources here for other ways to do usability testing. All right, we'll move on to episode 2. And this will be about preparing a rapid usability test. Fine. We'll start with defining tasks for a rapid usability test. And we've already seen an example of one. So a task should be something that users actually want to do, that can be accomplished in a short period of time. And when defining tasks for your rapid usability test, keep in mind that you don't want to do a test of users' reading comprehension. You want to test the usability of the interface. So it's good to avoid using terms that are visible in the interface in your task description. Nielsen Norman has some additional advice on how to craft good task prompts. So for example, when writing a task for testing, you want to avoid words that users can see. And you can see in the screenshot of the Slack message that reply and thread are both used. So if the task is, you don't want to say, how do you reply to a thread? You would say, show how you would participate in multiple separate conversations in one channel. So yeah, a user isn't striving to use threading, but they might in fact want to participate in multiple separate conversations. And then think about what success looks like for your task. Just as there's multiple ways to make errors, there might be multiple ways of achieving success. So if a user does something differently from you, that doesn't necessarily mean they're making an error. You can learn a lot of new ways to navigate your product with usability testing. So, threaded replies and tagging are two ways to succeed in maintaining multiple conversations at once. So you might need to be flexible about the different ways success can be achieved so you can recognize them when you're observing users. So after you've selected the tasks or the scenarios for your usability study, time yourself completing study tasks to establish a baseline. To prevent fatigue, you want to aim your session to be under 30 minutes and allow 10 minutes for non-task activities like instructions and interview questions. So no more than 20 minutes for task completion. And you can reduce the number or complexity of tasks you've planned if needed. And then we'll plan for a data collection. So before you begin your study, you need to be sure the data you collect will answer your research questions. So most usability testing for scientific software is conducted to answer research questions like, what pain points do users encounter when using the software? Or what issues keep users from completing desired tasks? So with your research questions in mind, consider what data you'll need to collect. So in the exercise, you have those two research questions. What pain points do users encounter when using the software? And what issues keep users from completing desired tasks? And then in the survey, you can choose the data that would be easiest to collect to shed light on these research questions. Options are quotes or notes from observing the user encounter a problem, notes about how severe or impactful each problem is, quotes or notes observing when a user finds things easy or likable, statistics about how long the user took to complete a task, survey data on a user's confidence while completing a task, information indicating if a user managed to complete the assigned task, and then information about how many errors a user made. So I'm going to let you think about that for a minute, and then we can discuss it. And if you have answers or things you want to say, please put them in the chat as well if you're online. All right, and do people have thoughts about what kind of data might be easy to collect? I guess you could say all of the data would be appropriate to include when answering, to help answer those questions, but some of it might take more effort than others. Yeah, so survey data, for instance, requires you to distribute questions to the participants. Statistics on the number of errors requires you to actually keep a log of each participant's session and count the number of errors you see. Information on how long a task takes requires you to consistently identify the start and end of a task and capture the time in between them. So while that can be valuable and it might be useful in certain projects, especially like in publications or to do, sort of metrics, you can actually learn most of what you need to know simply by capturing quotes or notes from observing the user encounter a problem, quotes or notes observing when a user finds things easy or likable, and notes about how severe or impactful problems are. So yeah, we'll talk about some other qualitative data. I'm sorry, that's qualitative data, and that's probably all you need for rapid usability testing, but some more common quantitative UX metrics are listed in the table below. So if these are applicable to your research questions, you can consider them. So they're listed here for your review. So successes, errors, clicks, completion time, idle time, drop-off rates, self-reported satisfaction or usefulness.
I would just add, you really don't need to focus on these, in my opinion. I think that like Jenny was saying, the qualitative idea of these usability tests is really what's more important. It's very hard to understand the completion time of something or the number of clicks. So especially if you're doing this for the first time, I wouldn't personally worry about these.
And there's also, I know there's like eye trackers and all kinds of high-tech things, but what I guess the key message is you can go there, but you absolutely don't have to, and you have all the tools you need available right now to do rapid usability testing. All right, so yeah, question.
I just had a question on the qualitative part. How do you make sure you're kind of getting enough input from people to make sure that you're not being biased by, so in your previous example, when you had like the pip person, if someone already knows Python really well, they might be like, I have no problems with pip, where if someone is just learning Python for the first time, they might struggle. So are there any thoughts or strategies of how to make sure your group is broad enough for the qualitative data to be helpful?
So that's a great question. So if you know that pip is your research question, like I'm having a lot of emails about people having trouble installing my software on pip, then that would be part of your recruitment strategy. So we'll talk more about that later, like how to recruit that specific type of user to help answer that question. Yeah. Cool, thanks.
So the qualitative notes in that you take, how do you suggest that you remove your own personal bias from the? Yeah.
Also a really good question that we will go into later, but yeah, it's, I guess one thing I don't think mentioned later, but I do think is important is that the facilitator, the person running it, might be more removed from the project itself and not be the developer of the software. So as a software developer myself, when I see usability tests, I'm like, I can't believe they didn't click the button. Like, it's so obvious. And yeah, I think if I was facilitating, they could probably sense that in me. But if I do it for a project I'm not so involved in, it's much easier to just let them figure it out. So, which also can be painful, but we'll talk more about that. So great. All right, we'll go on to data collection. So to learn enough to influence your development roadmap during a session, you likely only need to collect quotes and notes from your observation of users. So we just went through that. You can do very simple, just watching users, you will gain a lot of insight. And it's always surprising to me, like I feel like I always learn something no matter how seemingly mundane the task is. So even something as simple as what I did with Bhagyashree, just like look at the site, what do you think? You'll learn some things. So we highly recommend recording your sessions so you can reference them later and easily generate a transcript. You don't have to have a transcript, but tools like Zoom and Teams can automatically produce them these days, so it's much easier than in the past. Also, there's options online. I think they might not be free, but to produce a transcript. But again, not necessary. After you conduct a session, you may wish to document each error or issue and its severity, and episode 5 will talk more about how to use the information you've gathered. So if you include any survey questions, we recommend limiting yourself to 3 and asking someone to review them before you start collecting data. And you can always reach out to the UX working group. So again, that's User Experience Working Group in the ucar-sea, and there's a link to that. Or you can try asking the Strudel bot. So we looked at the strudel.science website, and they have a UX bot that you can ask for advice and feedback. So, All right, so asking survey questions with anonymous IDs. Often when verbally asked a question that uses a Likert scale, which is a scale of 1 to 5, so how easy was this task for you on a scale from 1 to 5, participants will hesitate to provide a number and might give a more expansive answer. So we recommend sending self-report questions like this as survey questions instead of asking them out loud, and Google Forms is a very simple way to do this. And then you want to link their anonymous survey responses to the study session, and you can do that simply by assigning a participant ID. Then the next step is developing a script. So it's important that you give each of your participants the same experience when they join your study so that the results are comparable across participants. And you want to avoid giving hints or causing confusion, and you also want participants to feel comfortable talking with you. So we recommend this kind of script with and you prep it and test it to make sure that you're going to succeed in your answering your research questions. The script should cover everything you're going to say to a participant so that someone else can stand in for you and still run the exact same study. So here's an example script. You start with a very brief overview of what you're going to be doing. You note the task itself is, make sure the task is a real world goal and doesn't use the phrase, in this case, direct message, I guess is what they're testing. So it's a script for studying the ease of sending direct messages. So they use the phrase, let's see. Well, anyway, so first you want to start with orientation for the participant and assure them that you're not testing them. It's not a test of the user, it's test of the site itself. And you will have rapport and warm-up questions before getting to the task itself, and then you'll wrap up. So during the orientation, you want to introduce yourself and outline what will happen during the study. Again, assure them they're not being tested. Conduct your research. If you're conducting your research remotely, you might not have direct control over the test environment the participants are using, so you can, help them not share things that they don't want to share. And then if any dependencies need installing, make sure you do that beforehand, and then ask permission to record the session. And when building rapport, you can ask the participant a question about themselves that they can confidently answer, but that won't take too much time. So it's recommended to ask an open-ended question about the tool or the profession or their skill set. And then when presenting the tasks, try to order them so that your most prioritized tasks come first. And if there's a logical sequence to them, you can apply that structure instead. If you're going to ask any questions about impressions of a particular feature or workflow, you should do so right after the relevant task. Don't save it for the end. And in your script, include links to any appropriate web pages or survey questions so they can easily share this information, so you can easily share it with participants, not like what we've been doing, like it's a little less smooth. But anyway, put them next to the appropriate task, not at the top of the page. And then when wrapping up, give participants the chance to ask your question and provide overall feedback on their experience with the product being tested. So after you've prepared your script, you can ask someone to help pilot or test out your study. You do this with someone who would make a good participant, but that, just basically you could use anybody. And then run the pilot exactly as you would a real session and keep track of any needed changes to your script. The most important thing is that the tasks are easily understood, and it's an opportunity to ensure the study takes an appropriate amount of time. So feel free to iterate on your tests. So, all right, and then there's some key points that you can look at later about this. All right, so what questions do you have at this point? And we'll do episode 3 and then we'll take a break. So any other questions or? All right.
If not,
you have a question?
Yeah, I think I'm just like prompting an idea. How do you think about creating like a priority list for these questions? I know you touched on it a little bit, but can you elaborate on that? Like how would you as a survey setter think about it? Because you may think something's important, but the user may not think. Anyway,
I think that it comes from your research questions. So it probably actually comes from debates you're having in the development group yourself. Like, what is the purpose of your software, and then somebody might say, oh, we need this feature. And then you could say, do we need that feature? Like some people might think, no, we don't need that feature. So it's a really great way to get over a lot of debates on development teams. Actually, some people are like, oh, we need a drop down. And someone else is like, I hate drop downs. And you can end up in this infinite cycle. So you could actually just get data from your users, if drop downs are appropriate in that situation. So often, so that's kind of a trivial question, I guess, like, do we need a drop down? But there's your research questions like, what is your software supposed to do? What is the fundamental purpose? So.
Yeah, I think to add, you can start with some binaries that you might want to have like a yes or no answer to. For instance, we had part of our tool, we were just curious if anyone used a feature. And if you can ask 10 people and they all say no, you can very quickly be like, okay, we don't need that feature anymore. So trying to get data to support those decisions that you're going to make within your software team, I think using these kinds of usability tests is really helpful.
All right, anything else before we go on to episode 3? Yes.
On your last point, right, about features that you get from your users and they say, hey, we're not using these features anymore, and you take it off. So I've had a situation where that happens, and then several months down the line, somebody comes in and like, hey, I've been using that feature, I can't find it anymore. What do you do?
Yes, so I guess taking things away can be very risky or painful. I guess it's different than rapid usability tests, but on my team, we also chart metrics of the features in Google Analytics. And so we can tell if they're used or not just from the people we've talked to, but I guess you'd have to get good data. And then you could just say, sorry, feature wasn't used. I mean, if you test people and they aren't interested in it, then you're not trying to please everybody, just your core group. So it's your team's decision and your own project's priorities for sure. Yeah. Anybody else have experience with something like that? Or
I think to add to your question, Primus, I think that when you take away that feature and maybe people still want it, and maybe you've decided within your software team this is an annoying feature to keep having to provide to the users, you have enough justification to be like, sorry, not available anymore. I mean, I know that's not like the best. Maybe this is me showing my commanding, maybe not commanding, but trying to make decisions quickly. I think we, like Jenny's saying, you can't please everyone. And once you have some data that backs up the idea that maybe this feature isn't being used by at least a subset of your users, it's just so hard to maintain something that everyone, is happy about. So you do have to make those tough decisions sometimes, but to each your own. I mean, if you want to keep providing a feature and keeping a subset of users happy, that's totally fine too. But it is complicated. I didn't want to make it sound like just eliminate something and don't care about anyone else. So that's a really good question. I appreciate it.
Yeah, and I had an experience recently. Oh, sorry, go ahead. Yeah,
I have a bad example of this, which is I deliver a piece of software that has this batch processing mode that somehow I accidentally broke while fixing something else, and nobody noticed for 3 years, which was how I learned nobody uses that anymore.
Yeah, actually, I was going to give a similar example where I was requested to make a feature by someone because I guess it was a feature, it was a thing that Swipsy used to provide, and then they stopped providing, and someone said, I get asked for this all the time. So I made a duplicate of that feature in a different application, and then it went down for like 2 hours one day, and I got 2 emails really quickly from users. So I was like, oh, wow. It was bad that it went down and users weren't happy, but I was like, we have users, like they're using it, and it is a valuable feature. So both ways is really good to notice. Yeah, if you actually, and also I think we've all done that on software teams where like, is anybody using this repo? I don't know. Like, let's archive it and see if anything breaks, and then you could bring it back if it breaks something. But yeah. Yes.
just to keep adding to the conversation of removing stuff, I have found if you're working on open source software and you need to remove something and someone's like, no, I need that, you can always just threaten them with they can maintain it if they would like, and then that tends to stop that. So yeah, I think
Yeah.
cool, yeah.
Like build your own app. Yeah. Yeah. So that is a good strategy. Like, do you have funding? Yeah. Good.
Yes. Yeah, I kind of have a separate question. So how might you handle in one of these tests sort of like a complete failure? So the user is kind of not getting to the point and they're kind of, waffling a bit. And at what point do you either, like guide them along to get them to complete the task or maybe, end the test?
That's a really good thing to keep in mind as we go through actually giving a usability test. And I think you can get so much information from failure. Like, I actually think failure is incredibly valuable in usability tests. So you shouldn't fear it. And I don't know if you should embrace it, but you definitely should have, you don't want to let them just completely fail. Like, if you have more than one small task, you can just give them a link to start over to go to the next task or, at a certain point. But you can get a lot of really good information and you can ask them, why are you confused? What are you thinking? All those things. And you get a lot of really good information. Yeah. As painful as it is, but it's important. Should we go on? We'll go on to episode 3. And this is about recruiting and tracking participants. So that'll answer some of the questions about, like the pip install issue. Anything else? Sorry, is there? Okay. All right. So who to recruit for your study? And recruiting can be one of the most difficult parts of usability testing. For example, if you worked at Slack and your goal was to find certain kind of Slack users, that might be a challenging task. But the really good news is that in academia, recruitment can be one of the easiest parts of the whole process. It's like we have a community and we know our users, and you don't need as much effort at all. So still, we're going to go through like as if it was hard, just so you can see what you don't have to deal with, basically, when you're in academia. So you want to consider, who the tool is meant to support and what your research questions are. So that's called a value proposition. So it's a statement of benefits. By considering what benefits you offer and to whom, you can identify the general type of person you should be recruiting for your study. So in this example, the research question is the example up here. Oh, I guess we should get to the example. Yeah. So this is an example from Slack, which would be a large industry, company. So the question is, when users return to the design after a period of not using it, how quickly can they add a channel? And so then the value proposition is, via synced phone, browser, and desktop applications, Slack revolutionizes team communication by enabling seamless collaboration and enhanced productivity in a dynamic work environment. And then your target study population would be Slack users who have not opened the app for whatever number of days, and you want a person who uses Slack for work with a team. So you could see that that might be kind of a challenging target population to find. But if you do have specific questions like that or about pip install, you might find people who are new to Python or something like that if you want to find people who aren't familiar with installation. So, all right, but then we'll go on to how many people to recruit. And there's more good news. Once you know what type of person you want to talk to, which in academia is probably like people you know, next you'll need to decide how many users you'd like to have in your study. And there's no wrong answer, but what's important is that you feel confident that the data you'll gather will be enough to make informed decisions going forward. So yeah, if you are seeking statistical significance, you'll need to recruit a lot of participants, but for rapid usability testing, this is not the case. You don't need very many participants to gain insights. So we recommend testing with just a few users. So more than one, like one is better than none, but one, and then so 2, and up to 5. You're welcome to do more than that, but in actual experience, there's diminishing returns. Like your first 2 or 3 users are gonna find a lot of the same problems, and that will be plenty for you to work on. So you don't, you can, if you have more users that you can test, it's probably better to just fix those important issues that you found with the first few users, and then you can again test with those other users that you know later on. So you'll get more bang for your buck testing buck basically that way. And then while usability studies outside of scientific software usually offer an incentive for participation, such as a gift card, in science that's not usually a common practice. Your colleagues are genuinely interested to see improvements in the tools that they rely on and to help you. So there's a sense of community and shared interest, and that is enough of a motivator for most participants. And they genuinely enjoy helping. Like, it really does build community because they might see how their participation changed your product, and that's really rewarding. And then, yeah, again, if you reach out to strangers, they're just probably not going to get back to you. But if you do know the people or you're in regular contact with them, you'll get a pretty high positive response rate. So, all right, and then in scientific research, we'll talk about how to recruit now and an example recruitment email. In scientific research, you can think about recruiting users as building community. We recommend just sending out simple, individualized emails to participants, and that gives you a record of when and who you reached out to. And then you want to be aware of privacy. It's usually not a concern in public websites, but you do want to let people know how you'll be using this data and what you'll be doing. So we have a sample recruitment email that basically outlines the key points that you would want to include. So feel free to go to exercise 4, evaluating an example recruitment email. And it outlines the main elements a recruitment email should include, which is to address an individual. It's not a group email or spam. It introduces the sender and the research team, summarizes the goal of the study, explains what you want from the participant and why you're asking them, the time commitment, eligibility requirements, if any, there might not be any, and then any risks the participants might be subject to and how you will mitigate them. Tell them how you'll handle their data, make clear that it's voluntary, and if you do have an incentive, you can mention it, and then ask, for a clear answer on participation. So you can see, I think this email doesn't have all of those. The sample email, is it up there or not yet? Okay. So this sample email, I think it is missing a couple of those. So yeah, it does address an individual. It introduces the sender, summarizes the goals, and explains why the user, how much time they'll need, how the data will be handled, that it's voluntary. The two things that aren't in this email but probably aren't really needed in academia are eligibility requirements and any incentives that will be offered. So again, that depends on your study, and you can use the tools you need. I guess the main thing, the other considerations is that you don't want these emails to get too lengthy and overwhelming. So that can reduce your response rates. So you want to respect people's time and attention spans. If you are going to include an informed consent document, which there's a link to an example here, you might want to keep that separate or link to it, not included in a long email. You might need to go through an institutional review board, depending on what your research is. So again, this is specific. Any questions on that part? Do people in this room feel like, or online, that in their field it would be difficult, or have some privacy concerns or anything like that with usability testing? Or I think if we were in, neuroscience or biology or something, it might be trickier. Or but again, this is the good news. Like, we don't, most of the time for scientific software, it's not a big concern. All right.
I have a question too. Do you all think that it would be easy to find users that would want to participate in these kinds of tests? Like the sense that Jenny was talking about with community, that you think people would want to provide feedback to your tool? Yeah, I'm getting some nods. I feel like that's been my impression as well. Like Jenny was saying, you don't have to pay these people. They're very willing to help add to the tool and make it better for the rest of the scientific community.
Yeah, like when has a scientist not wanted to offer their opinion on something?
I don't know.
So, yeah.
And one other thing that I wanted to add about, well, I think we're getting to this, like the length of time for the
Yeah, I think we said 20 minutes with adding, 10 minutes for questions and things. Is that what you?
Yeah, when I did these recently, I just scheduled a meeting for a whole hour, and that just gave some more wiggle room to say like, okay, I'm only going to ask you 5 questions, but if they really want to elaborate on something, kind of like what Marley was saying, if they get confused or stuck at any point, it gives you some time to be able to guide them back to maybe where they need to be going for the test. But if you want to really make it short and quick, you can definitely make it only 20 or 30 minutes. And as Jenny is saying, all the scientists definitely want to give you their opinion. So that should be plenty of time.
Yeah, I had one usability test where it was filling out a long metadata form. And we did a lot, 50 minutes, but it felt really long and brutal. But I guess that's what we learned from the test as well, that it was long and brutal. So yeah, and then, you think about it too, like, if you allow an hour a test versus 30 minutes a test, you're doubling the amount of time, about scaling and efficiency. So that's not, that doesn't scale as well. So yeah, it's totally up to you and your research questions. All right, now we'll go on to, how to track your participation. And this is probably more detail than you really need, but I think it's nice to have this formal way of tracking participation. So even with just a few users, it can be helpful to have a central place to keep track of who you've recruited and when, if they'll be participating. And so here there's a template spreadsheet for this. And it's really helpful to see when people were contacted and followed up with, and then also keep links to the session transcripts or recordings and notes. And yeah, so this is a sample participant tracker that you can make a copy of and use yourself. And in your participant tracker, you can assign participants anonymous IDs like participant 1 or P1 so that you can identify them and their data without using their name. And this private tracker should be the only location where you link anonymous IDs to identifiable information. So if you don't have to record identifiable information, just don't do it. It's not that important. But since this workshop's focused on smaller cohorts of users, tracking them is probably not that complicated, and it can still be helpful. But yeah, I'm going to go on and show you like how you can use a participant tracker and then organize your files so that you keep the identifiable information only in one place, and then you can link to more anonymized data. So this shows, are we on the, yeah, do we have the next thing? This just shows a sample structure of how you can do that. So trying to minimize where you have identifiable information and what you share in Google Drive, for example, with who. So it's a nice graphical illustration of how you can organize those materials to keep confidential information in a controlled environment. Yeah, so before we go on, I think we'll take a break before we go on to episode 4. But what questions, any other questions people have about participant recruitment and target populations? I hope that answered your question about the pip install.
Like, I have a question about the statistical significance aspect of things. So,
oh, great! I'm the wrong person to ask.
No. I mean, it's about how do you maybe with thinking about yes, no versus like 0 to 5 scale, like that kind of stuff is easy in my mind to do a statistical analysis on. But like, how do you do it on like a descriptive answer?
I'm glad you asked. I guess this workshop is really not going to talk a lot about in-depth ways to do a qualitative analysis of your data, but luckily, one of the people from ucar-sea who helped develop the curriculum is giving a workshop specifically about that in May. So I will have links at the end for that workshop. So if you want to do some usability tests between now and May, and then go take that workshop, it's free. To learn more about that, that would be great. Yeah. So. All right. Anything else before we take a 5-minute break? Is that dangerous to take a 5-minute break? Are we okay? Okay. Yeah, we should have a little. All right, we'll see you back here at 2 o'clock. All right, it's a little after 2. We're going to get started again. So. All right, welcome back. We're going to start with episode 4, and this is the fun part, actually conducting a rapid usability test. Oh, did you have a question, or are you just, okay. All right, so here's some tips for ensuring smooth data collection. So having determined your tasks and written a script, prepared your participant tracker, and recruited participants, most of your work is already done. So before each usability session, send a reminder to your participants, and if appropriate, include the link to the video conferencing tool you'll be using, like a link to Zoom or Teams. In your participant tracker, mark down that you sent the reminder. And before the session begins, make a unique copy of your script, and you can include the anonymous ID you've assigned to that participant in the title. And then you can use that to take notes. You might take notes in a different color, like blue, so that you can distinguish what you should say aloud from your notes. What you should say aloud from your notes. And then you can link to that copy of that script and your notes in your tracker. So during the sessions, participants will need to share their screen. Encourage them to only share the needed application, for example, a browser window if the product being evaluated is in the browser, or a terminal window if it's in the terminal. And when sending survey questions, tell the participant they can open the survey in a different browser window so that they have privacy when responding. And then make sure these suggestions are included in your script so that you don't forget to say them. And with small studies, getting more qualitative data, like non-numerical data, can help ensure you gather rich insights and you don't rely too heavily on interpreting trends from small sample sizes. To gather this data when orienting your participants, tell them you'd like them to think aloud while they work on tasks. This is something unnatural and might slow participants down. If you're using speed as a metric, you might want to reconsider this approach. But again, we're looking for more qualitative data, not metrics. And if you want to get more information on a participant's impressions, it's really helpful to ask them what they're thinking. If they stop talking or they feel like, they don't want to do something wrong or whatever, you can just give them prompts like, what are you thinking? Tell me what's going through your head, and remind them to think aloud, because it's not an instinctual thing to do. Sometimes participants might quit a task without finishing it or might get quite lost while attempting to carry out the task. I think that's what Marley was saying. Assure them that this is okay and you're learning a lot from them. It's really important not to give any hints. So you want it to be a real situation. You're not going to be sitting next to your users, so you can't really help them in the moment. But you can have links and needed information on hand to send so that they, when you start a new task, they aren't completely lost. And again, assure them that that's really actually helpful to you to see where they go astray. And then it's extremely tempting to fill in gaps in conversation. However, intentional silence can be a powerful technique for moderation and learning more from participants. So work hard to hold silences past your comfort point so that your participant fills in the space, not you. Just wait in a relaxed manner. If your participant asks a question, try offering a non-committal or if it's during a follow-up interview, you can encourage them to go on by saying, tell me more about that. And you can tell them beforehand in your script as well that, like, I can't answer questions that you have, and that's okay. I can do it after the test is over. So yeah, if you're part of a team with the capacity for more than one person to help with a rapid usability test, you can plan for different roles and responsibilities. You can have one person verbally facilitate and another person take notes, and other people handle the technology. So, all right, so now we're gonna do an exercise where we see what it feels like to think aloud. I guess we're gonna try to pair up in the room, and then I'm gonna ask Fletcher, I think, is Fletcher there? Yes, hi, to make some breakout rooms for 2 people at a time. So if you're actually on the Zoom in the room, maybe you could get off so Fletcher doesn't assign you to a breakout room, and instead you can work with a partner in the room. So in this, yeah, so I guess we can go ahead and do that. And I don't know, just actually on breakout rooms, do they see the main share screen? Yes? Oh, really? Okay.
Yeah, I think we can go over the exercise first before we go into the breakout rooms.
Okay, great. So in your groups, you and a partner will act as a study facilitator and a participant in a rapid usability test. To save time in this scenario, we're going to skip some other portions of orienting participants and the usual warm-up questions. So it'll be quick. You choose your roles. One person is the participant. They will share a browser window, and then the facilitator will read the script aloud, and the participant will engage in the assigned task. So the facilitator can take notes in the place of their choice, and then you will, after a little while, tell you to swap roles. And then we'll discuss the exercise as a group when we're done. So yeah, so I guess, is the script up there? Yeah, okay. I think this is a short enough link to just type in yourself. But yeah, I guess we should just let you guys go and do the script, yeah. So partner up.
Yeah, and if you're online, Fletcher set up breakout rooms that you can join.
we're available up here too if someone. Yeah. And if, yeah, feel free to switch even if you haven't completed the task. Or maybe you've already switched and that's fine too. I will wrap up in about 60 seconds, so get all the data you can. All right, Fletcher, we can close out the breakout rooms and come back to, everybody can come back to the central meeting. All right, who thought this was a challenging task? Anybody? Challenging? No? Yeah? Okay. And I guess two parts could be challenging. One is being the participant and the other is being the facilitator. So as a facilitator, did people feel it was hard to stay on script? Yes? Yeah. And that can be because the text doesn't suit your style of speaking. So you can write the script in a language that feels comfortable to you. But yeah, it also is just not a natural thing to do to stay on a script. And then what about the thinking out loud part? What are some people's feelings about that? Yeah, Primus.
So I'm more used to internal dialogue, and so I was thinking about it in my head as I was going through it. But then he's like, "Oh, hey, you have to think out loud," and yeah.
Good job, facilitator. Yeah. Yeah, Jesse.
I'll just say as a facilitator, I found it hard to just let them talk out loud without responding. Like usually I don't just say, tell me more, and then, yeah, just keep going. So that took some effort. Thanks.
Yeah, it's good to practice for sure. And then did anybody feel like as a participant that they should know what they're doing, or they, like it's hard to talk out loud when you're not sure what you're doing, I guess.
Yeah, so Sam had a comment online. As a participant narrating, my thought process was hard. Also, narrating out loud does slow me down, and that would impact measurement of efficiency. So I think that's getting at what you're asking. Like, it is harder to talk out loud and kind of think in a different way as the participant, and that might then like skew your results from the testing.
Yeah, and as academics, we don't want to be wrong, I guess, or so it's not natural to narrate something unless you feel confident in what you're doing. Any other impressions or thoughts about how that went? Yeah, go ahead.
Yeah, I was wondering if there's a way to handle the neurodivergency part. Like, some people think differently and, compute differently in their minds. So like, if you were to have like a diverse set of people take such tests, like, should people think about the neurodivergency part?
Yeah, I mean, that's actually one of the really nice things about usability tests is you do get a variety of people and they will respond differently to your software or tool. And yeah, you can kind of tell, like, some people will have a really hard time thinking out loud, and that's okay. But then some people will approach things in a way that you never would have thought of, and that is also really helpful. So it is actually great because I don't think there's a wrong way. Like, again, the user is right, always right. But it is nice to see individual personalities and styles coming out, and that's really realistic.
Yeah, I think to add to the neurodivergence comment, one thing I had debated about when I did these tests is if I should send the questions out to the users before conducting the test. I think it can go both ways. You don't want people to be like completely scripted and totally prepared for the questions that you're going to answer them. But I think kind of what we were talking about before, if someone gets completely stuck and is kind of like not saying anything, that's not the most, failure is helpful, as Jenny was saying too, but I think that can help with neurodivergent people, as well as if you can send them the questions beforehand, maybe not like all the follow-up questions that you're going to ask, but maybe send like the top 3 topics that you're going to go through. That can be a really good way to help them prepare for the testing as well. But on the other hand, sometimes you want to catch people off guard too, so it kind of depends on what you really want out of the testing.
Yeah, I guess it makes sense to let them know what the test is going to be like. Like, it also just sounds intimidating saying test. Like, maybe it shouldn't be called a test, like a session, or an exploratory session or something. Because if you feel, again, like we're going to be triggered by the word test. But yeah, to let people know what to expect. But you do consider if you want a real world situation, like if your users aren't going to be prepared, you might not want your participants to be prepared either. So.
Maybe you've thought about this, but I realized I'm not a very good facilitator. Is there a test to test how well you are as a facilitator? If it's something you feel like you're going to have to do, but you're not good at it, like, is there anything that would help a facilitator be a better facilitator?
I would say practice, and then like sticking to the script and just sticking to the script. Like, it's really hard. And then practicing the pauses, maybe count to 10. But I don't know how you could not, what do you mean not a good facilitator? Like, how do you know you're not a good
like middle child syndrome. You want to fix all the problems, right?
Fix all the problems, yes.
Yeah, like
of course
said,
you do.
Not waiting long enough, not letting them struggle. enough?
Yeah, I mean, if it's your project or your piece, your tool, get someone else to facilitate, and you'll have less investment in it, I guess. Yeah, and fix all the problems. Yeah, I guess.
I'm curious if there was any, there's plenty of material about how to get through all this, but not as the facilitator. That was something that had crossed your minds as a way to also improve, because that's part of all of this is being a good facilitator.
Yeah, I think that's a great question. And when I did these tests as well, I actually had 3 different facilitators, which I guess maybe is intimidating for the participant. But like I had my supervisor who also was just there to basically listen in and so that he could hear how the users are reacting